So I'll be talking a little bit of hardware also, because hardware and software, they go hand in hand. Without understanding of those hardware, very difficult to implement this AI for video processing. So, 2 years ago, when I was attending a conference in the United States, so I saw this machine. They call it the ultimate AI machine. And I waited there for more than a couple of hours, and I could not find anybody to beat that machine. So that is the status of AI today. So now let's start the topic. At the first place, what is intelligence, right? We need to understand that. So intelligence is the ability to make the right decisions based on certain criteria, and these criteria we define based on our prior knowledge or training, right? Since the birth of a child, we learn. We learn every day, we learn every moment, and some of the patterns we follow. And based on that learning, lifelong experience, the knowledge we acquire, based on that, we create certain intuition. So human intuition plays a very, very important role in the intelligence. People who are more intuitive can assess the situation, can make proper decision, a right decision, and people who make the proper decision based on the knowledge and intuition, they are considered to be more intelligent compared to others. So this human intuition plays a significant role, and modern AI has something to do with intuition. That's why I'm mentioning this. And even, these days, AI research, it is not only just computer scientists or mathematicians are involved. I'm associated with many universities. So in the United States, I have found even the people in the history, people in the psychology, various domains, it became a multidisciplinary research. So psychologists, they say that human intuition is characterized by pattern recognition. When we determine certain things based on the prior knowledge or previous knowledge, and that previous knowledge forms some patterns. For example, looking somebody, we may like that person, we may not like that person. Based on certain patterns, based on certain experiences, we immediately form an opinion of that person, right? So those are the patterns. So pattern recognition, understanding of the pattern, recognizing the pattern, characterizing the pattern is a very, very important aspect for artificial intelligence. So this is intelligence all about. Then what is the artificial intelligence then, right? So machine learning techniques, basically attempt to computationally model the world around us, and by modeling that world around us, based on the data fed to them, does some pattern recognition and generates some decision-making process, and which demonstrate the notion of artificial intelligence. So that means intelligence is being imparted to a machine, and based on the machine learning techniques, various tools, it makes certain decisions. And in general, that is the artificial intelligence, and pattern recognition plays a major role in AI, as I mentioned in the previous slide. Why human intuition is so important for intelligence, and why human intuition is formed based on the pattern and the prior knowledge. So that's why pattern recognition, understanding of pattern recognition is a very, very important to become successful in AI. There are various branches in AI. AI is not new. AI is going on for last 50 years, rather 7 decades. So, when we were graduate student in early 80s, That time also we studied artificial intelligence, but every decade, character of the artificial intelligence is changing. In today, in the context of image and video processing, this artificial neural network became very, very important tool for the AI. So since I will not be able to cover everything within an hour, I'll focus mainly few slides on the artificial neural network to give you the basic understanding and what is the latest development over there and how they are applied into the video processing. So what is this artificial neural network all about? It is essentially computationally attempt to mimic the learning capability of the biological neural system. Biological neural system means our brain, right? So using a computational architecture, right? So using a computational architecture, mimicking the learning capability of the biological neural system, that is called artificial neural network. So if I look into the history of AI, essentially, Alan Turing, he first thought about a machine can think, right? And based on that, in 1950, he has shown a model and he did some Turing test. And in his name, when the machine was developed, it is called Turing machine, right? Using that, he has first shown, yes, to a limited extent, machine can think. So Alan Turing is considered to be the father of theoretical computer science and artificial intelligence. So you can see this, during his lifetime, artificial intelligence, computer science, it literally started. To me as a socially conscious person, the first real life and significant application of artificial intelligence which impacted the life of people, that was during the Second World War. Dr. Turing, he actually did some work on cryptanalysis by which, during the Second World War time, could decipher the secret information used to be sent by the Germans, right? And by deciphering those, secret information, Second World War actually could stop, 2 years before, it shortened the Second World War by 2 years, and it saved over 14 million lives. So to me, that is a very, very important aspect of the artificial intelligence, that artificial intelligence could stop the war and artificial intelligence could save the life of 14 million people. So that is very important to me, and that's why this father figure of artificial intelligence, Alan Turing, in every lecture, I remember him. After that, many people during that period, lots of genius were born, and many people contributed to this. One of them is Claude Shannon. Claude Shannon, 1949, probably people who are in the communication field or information theory, they have heard this name, Shannon's theory. So Shannon is the father of communication, okay, father of information theory. So 1956, three great minds, Shannon, McCarthy, and Minsky. With these three minds, one great researcher, Rochester, also joined. So they first gave this term artificial intelligence in a proposal for a conference, and the conference happened during the summer 1956 in a college called Dartmouth College, a very good college. In that conference, they first submitted a proposal, okay, a position paper. So 1956, during the summer, first artificial intelligence, the terminology was coined. And you can see, Shannon, the father of communication, McCarthy, his work into information theory is historical. Minsky, his work into the mind theory and AI is fantastic. Rochester was one of the guy to first realize a practical Turing machine. So 1947, this concept started. 1956, this idea was coined. The other, significant people to remember is the Frank Rosenblatt, 1957. He first developed the perceptrons, and perceptrons was essentially the beginning of the neural network. You can read in the book. I'm not going in detail over there. Later, Minsky, he first wrote the book on perceptrons, and one of the key contribution he has done, he published a book. It's called The Society of Mind Theory. How mind works, the Society of Mind Theory. And he is the first one who developed a universal Turing machine, taking the clue from, he was actually a Turing student, from Turing concept, Turing test, how to universalize it, he developed the Turing machine. And Papert, he took this perceptron to a newer height, and that became the practical artificial neural network. Then, Fukushima 1979 gave the concept of multi-layered artificial neural network, which is the status of today. Everywhere you hear deep learning, not many people understand what is deep learning all about. Even the panwalas these days talk about deep learning. Other day I was in a pan shop, the guy was telling that his son does deep learning. So I got scared. So the deep learning or convolution neural network, that actually started from new cognition. The new cognitron, the concept was given by Fukushima. And today, this theory is planted the seed of the deep learning technology. So I'll be covering little bit of deep learning because including the panwalas has interest into that. Okay. So what is the deep learning all about? And this is the perceptron machine. So before I go to the deep learning, what is this neural network all about? Like in human brain, this human brain or this human cognitive system, this is the composition of billions of neurons, right? Neuron is the fundamental element of the nervous system. So in mathematically, it is a relation like this. And let's assume the formulation of Z equal to, this is the formulation. And what is this? There are several inputs, x1 to xm. You do the weighted multiplication, you add them, you bias them, you generate certain number. And what is this? This is analogous to FIR filtering. And what is FIR filtering? People in the signal processing, they understand finite impulse response, essentially entire signal processing. That is, digital signal processing that relies on finite impulse response, FIR. And if you look at any digital signal processor today, essentially that is nothing but a MAC machine. MAC means multiply and accumulate. So each and every term over here is a multiplication, xn, yn, xn, wn, xi, wi, right? Multiplication. And accumulation means summation of them. So FIR filtering, that is the fundamental concept. And using that, you output of that FIR filtering, you apply an activation function. By activation function, you generate certain binary numbers, a number in between 0 and 1. Okay. Here I have used the sigmoid function. Depending upon the application, you can use many other functions, right? So this is essentially, there are inputs and output is a number between 0 to 1. And that gives the, a neuron does that. So that is the function of a neuron. Collection of such neurons, okay, it makes a neural network. How I'll discuss later. So how this kind of FIR filtering can be helpful in a real life, for the benefit of the students, I'm just showing a small example. Let's assume there are two neurons, right? So these are the weightage functions, and these are the two inputs, 1, -1, and those weightage, W1, W2 I was talking about, previous slide. So these are the weightage function. If you follow this, mathematics, it will give you an add 1, 0, it will give you the result 4 - 2, right? You do that activation function, sigmoid function, it will give you the result 0.98, 0.12. So we call it, say, one level. So I took the input x1, x2, I'm generating the output 0.98, 0.12. Now again, I can take 0.98, 0.12 as an input, apply to another level, getting some result. Again, I'm taking that output, applying in another level, right? Finally, I get the desired result, y1, y2. So this is fundamentally, I took a very, very, small matrix operation to explain you, how this is mapped into a neural network architecture. So essentially, there's an input layer, right? X1 to Xn, there are multiple inputs. In every layer, you essentially do the multiply and accumulate. After the multiply and accumulate, you apply some activation functions. You generate a series of output, call it layer 1, then output of layer 1, again do the same kind of computation into the layer 2, and second same kind of computation like this you can do in multiple layers, right? And you generate the output. So the layers between input layer and output layer, those are called hidden layers. Deep learning, deep means how deep these hidden layers are. More and more hidden layer, deeper and deeper. Small hidden layers, shallower. So this is the very, very fundamental of the deep learning, how deep learning works. How it is related to the so-called intuition or perception, which I was talking about earlier, right? So let's take an example, right? Let's say these are the pixels in terms of image processing. So looking at this, you cannot make any decision, or you cannot make any assessment of this. What is this all about? So you can take those pixels, apply through a first layer. Okay, after applying first layer, maybe you can see some edges. Then you take those, again apply to the second layer, you can get some object parts. Again, you can apply to the another layer, third layer, you can get some objects, human faces, from edges to nose and, body parts, human face. Then again, you can apply to another layer. From the human faces, you can extract many other information. So that's why in the previous slide I said deep learning is nothing but learning hierarchical representations of features. Edges are features, objects are features. In image processing there are many features. Object features. Objects has many features. So in multiple hierarchical representation. So in the hierarchy, first layer I'm extracting some edges. Second layer I'm extracting some curvature, right? Third layer I'm extracting more detailed information, maybe the faces. Following layer I can extract more information, maybe the skin tone, etc., etc. So this is what deep learning all about. So mathematically, there are many forms of deep learning. One of the deep learning, which is popular these days and everybody talks about it, which is called convolution neural network. And convolution neural network is particularly important for image and video processing because image is nothing but a two-dimensional signal, right? Into the two-dimensional signal, you can take a kernel, you can convolve it. After convolving, you generate, by convolving, you generate certain, information. In image processing term, machine learning term, that is called feature extraction. So in multiple layers, multiple features are being extracted. And there is certain, concept of stride. I'm not going into the detail. Depending upon the stride, from one input, you generate multiple layers of outputs. To reduce the exploration of data, right? So you do the subsampling. And in terms of neural network, they don't call it subsampling. Later I'll tell you what are those. Essentially, the subsampling is nothing but redundancy of the, reduction of the redundancy. That means you are taking out the redundant information, only keeping the meaningful information, so the amount of data does not go out of hand, because essentially you have to process by the computer, right? So like this, in multiple layers, you can, this is layer 1. Essentially, you have an input image. You do the feature extraction using some convolution technique, using some convolution, matrix, and depending upon your application, you choose those convolution filters. Okay, then you generate in layer 1 certain information after subsampling. Then you can apply the same thing into the next layer, and you can see from one image in the first layer, for this particular stride equal to 5, I've generated four images. Then from 4, I can generate 8 images. From 8, I can generate 26 images, and each layer has a meaning, right? So just to give you an example mathematically, so this is the original data. Let's assume this is the original image. And using a sliding window, I am just convolving, and let's assume there are 2 types of convolution filter. Okay. So sampled image is there, and convolution filter is the one there. Convolution filter, like wavelet transform, all depends upon what kind of information you are trying to extract and what kind of applications you are trying to do. So the same convolution filter which you are applying in medical imagery, it may not be applicable to other kind of image processing techniques like video processing. Same kind of convolution filter may not work. So depending upon your application criteria, what you are trying to achieve, carefully you have to select the convolution filter, or you have to design the convolution filter, which is done by the mathematicians and signal processing people. Your Professor Acharya is an expert into that. So after doing this convolution, so you get a filtered data, and let's assume this filtered data, which I am showing into the green, let's say it is a 4x4 filtered data, right? So let's say first 2x2, if out of those 4, they are almost the similar values, 58, 47, 44, 35, those are called, there is some redundancy, visual redundancy, involved. So out of those 4, if I take the maximum value, so 58, 47, 44, 35, that is 58. Similarly, next 2x2, 29, 17, 32, 14, maximum is 32, like that. So that is called max pooling. In a previous slide, I was talking about the subsampling. Neural network people, they gave a fantastic, name. They call it pooling. So if I am taking the maximum value, it is called max pooling. If I am taking the minimum value, it is called minimum pooling or mean pooling. If I am taking the average, it is called MEAN, mean pooling. There could be other kind of pooling also. Again, depending upon the application criteria, how you are going to subsample it to restrict the, exploration of data, in a large amount. So what kind of pooling technique you will apply, what kind of subsampling technique you will apply, that is the part of your research, depending upon your application. So this is in general, very, very fundamental of the convolution, neural network. So after this brief background, often people ask me, what is the difference between, traditional machine learning and deep learning techniques, right? This knowledge is very important. Traditional machine learning, earlier when we used to do the machine learning research, we used to develop the handcrafted features, okay, and which performs well on small data. In deep learning, no handcrafted features are there, right? And because if you choose the right kind of kernel for the convolution filter, it will automatically, there are theory behind it, automatically features are extracted in every layer and the performance improves with scale. Means first layer you will get certain features, second layer you will get finer features, third layer you will get even more finer features, and so on, improves with scale. But in case of machine learning, these are handcrafted features. That means you have to give, you know, those kernels and etc. And there can be multiple such things. And hard-crafted features are identified and extracted by experts. But in case of machine learning, you know, deep learning, you know, automated extraction happens. You don't have to extract those information, then supply to the next stage. In deep learning, it automatically happens. And in traditional machine learning, earlier the way we used to work, we used to decompose a big problem into smaller problems, solve those smaller problems, then accumulate them to find the ultimate result. The promise into the deep learning is, whether it is not there yet, the promise is it advocates solving the problem end to end. That means you don't have to decompose the problem in smaller parts. It is not there yet, but that is the direction it is going. Training time is short, seconds to hours, because you know machine learning works in a small amount of data. But in case of deep learning, you know, you need huge volume of data. That's why these days, you know, big data analysis happens, right? So there it can be days or weeks. So there are many techniques, you know, decision tree, linear, like I was telling earlier, predicate calculus, etc. Artificial neural network is one of them. In case of, you know, deep learning, it is a near human decision-making process. Okay, performance to the extraction of knowledge from huge data. Small amount of data, deep learning will not give you the promising results. So to do the deep learning, huge volume of data is required. You know, in sometimes in video processing, you need thousands of hours of video to process. Just mere 1 hour video, 2 hour video is not going to give you the desired result. That is our experience. And since, you know, this is the handcrafted features are extracted and smaller amount of data, that's why machine learning is good enough to do with CPU, you know, central processing unit. But deep learning, you know, huge volume of required. So usually multi-core computing is required. You know, 8-core, 16-core, 24-core machine these days, those are called multi-core machine. Or GPU, you know, graphical processor unit, VPU, you know, this kind of processing capabilities are required. Why this kind of processing capabilities are required, how they are different from CPU, maybe in one slide I'll cover that. So essentially, you know, CPU, you know, these days, you know, you have a 4-core machine, right? That means essentially there are 4 arithmetic logic unit, 1 cache, 1 DRAM, 1 control unit, right? But in case of GPU, you know, of course, you know, GPU started with the graphical processing unit, but these days it is not restricted to graphics processing only. It is called GPU, general purpose GPU. That means it can do other type of operation as well. So instead of 4 or 8 or 16 arithmetic logic unit, it can have thousands of logic units. You know, recently I am dealing with a machine which has 256,000 arithmetic logic units, and no cache is involved. Okay, very much local cache, but the entire thing is a, you know, dynamic memory, RAM, dynamic memory, and how they work I'll show in the later. So that's why these days deep learning became very, very popular and practical because of the advent of the general purpose GPU architecture. And it has a defined programming model, which is not quite same as CPU model. So understanding of the GPU and the programming model and how it operates inside, very, very important. Because in computer architecture, usually in the college, they teach 4 types of computer architecture, right? You know, SISD, single instruction, single data, SIMD, single instruction, multiple data, MIMD, MISD, right? But this is beyond that. What is beyond that? There is no computer architecture book which explains, but I'll explain you that. Why GPU is not just, traditional von Neumann bottleneck based computer architecture. Okay. So essentially, GPU computing, there are multiple SIMD units. If you look at each such unit, it's SIMD, single instruction, multiple data. And multiple SIMD units are operated together. And these SIMD units, each has a local memory as well as local shared memory. And they are all connected to a global memory. And GPU use the threads, okay, instead of vectors. So SIMD machine, single instruction, multiple data machine, they use the vector processing. Image processing, signal processing, those are, you can take an image, you can vectorize it. And when you vectorize it, you can run through a SIMD machine. Traditional, modern DSP processors are nothing but SIMD machines. But in case of GPU, there are many such SIMD machines and multiple such threads can work in parallel, which is required for the video processing. That's why the programming model is called single instruction multiple thread machine, SIMT. So traditional computing, SISD, SIMD, MISD, MIMD, right? In case of GPU, it is SIMT, single instruction multiple thread. So because there are several thousands computation elements are involved, and it can compute billions of data. So time is short. I just want to fast through. After saying this, all these things influenced the growth of AI today. The storage, huge volume of data is required, right? Computing, huge computational power is required. 20 years ago, we could not do that. But now we can do that because of the advent of the GPU and multi-core computing. Communication, we have to transfer the data from one place to another. We have to accumulate data. Today's communication, high-speed network is suitable to exchange the data and to gather the data and send it to the cloud. And because of the cloud, huge billions of bytes, rather I should say trillions of bytes of data can be, repository can be developed into the cloud. So the progress or advent into the storage, progress into the computing, good communication bandwidth, and recent advantages into the cloud, all these four together influenced today's artificial intelligence, right? So let me stop here. So we talked about huge volume of data is required, right? So today, the political slogan in the world is the nation that leads in AI will be the ruler of the world. So if in India, if we want to become really strong technologically, economically, and a leader, we have to be strong into artificial intelligence. Just following others, universities, just copying others' papers and reading those papers, and what are the loopholes, just doing those research is not going to lead anywhere. So essentially, we have to build our own AI model, our own AI research. And I'm very happy that your institute took that initiative. But please don't copy others. Do something fundamental of your own if you want to serve the nation. So this is Mr. Putin said, the nation that leads in AI will be the ruler of the world. And we need to indigenously develop our technology in India. Why? I'll give you a couple of popular examples. For example, in video analytics domain, people call unattended object, right? So this is Europe. I took this picture in Holland, morning 6 o'clock. So in the railway station, literally there are no people. If somebody leaves a bag over there, it does not take a rocket scientist. a high school kid can develop the technology to identify there is a bag, there is an unattended bag, right? Very simple. But this is Howrah Station, morning 6 o'clock. Do you think the technology which will work in this European scene will work in Howrah Station? It is not going to work. Even a cow poops, that will be treated as an unattended object. For example, this one in Japan, this gentleman left the bag and walking away. It is very simple to detect that this is the bag and this is the gentleman. You can do the association. This is Lucknow Street. How are you going to identify who left that bag, right? Which might have suspicious objects into that. So that's why for the nation, we have to build our own AI, our own technology. Just borrowing the concepts from foreign countries and foreign authors is not going to do much. We have to think fundamentally. Similarly, traffic problem, left hand side, this is my house in Arizona. Such a fantastic manner the house, cars are running, right? So traffic monitoring technology which applies over there, if I am going to deploy the technology in Moulali, it's not going to work because there is chaos. There is no rules. Nobody follows the rules over here, right? It's not going to work in Delhi. So that's why we have to build the technology for our nation, okay, to solve our problems. So what we are doing all about, after giving all these lectures, you might ask the question, okay, Dr. Acharya, what are you doing? Yes, we are doing something in Videonetics. We have developed first Indian AI DL framework, indigenously developed, our own framework. People will be using, I'm sure you guys use Kafka, this thing, that thing, YOLO, right? Those are all from the foreign countries. They work for the foreign environment. It will not work over here. We have to create our own Kafka type model, our own YOLO type model, our own framework. We have developed the India's first AIDL framework, and more than 100 use cases has been developed. Let me show you some examples, right? So for example, in this particular scene, it is in real life in Chennai. So there are so many cars. With traditional image processing technology, it is not possible, or traditional machine learning technology, it is not possible to identify each and every car. But here you can see even the partial view of the vehicle, even at the far end or far near, irrespective of the resolutions, those objects can be identified, classified, and detected. That is because of the AI and DL. For example, this is an example, during the pandemic time, the hygiene is very, very important. This is running in one of the 5-star hotel. I cannot name the hotel because of the secrecy. How do you know what is happening inside the kitchen? Are they following the pandemic norms? Are they wearing gloves? Are they wearing hat? How do you know they are not wearing the gloves or hand is washed? So automatically detecting those is very, very important, whether pandemic norms are being formed or inside the kitchen, hygiene is being maintained. So automatically those are monitored by the camera, and if there is any violation, immediately alert goes. So this is happening in one of the 5-star hotels during the pandemic time, right? This is operating in Bangalore, the bus station. So to make sure the social distance is being maintained or not, crowd count, if there is a beyond certain number of alert is going, and if the social distance is broken, alert is going, so the people take action. Similarly, whether this gentleman, wearing seatbelt or not, if somebody is driving the car not wearing seatbelt, automatically this is being detected, right? Because in India, many accident happens, and not because wearing the seatbelt, people lose life. So using this deep learning technology, we have developed the technology by which automatically through the windshield, you can detect whether the person is wearing seatbelt or not. First time it was deployed in Madhya Pradesh, in the city of Indore. Now it has been deployed in more than 100 cities in India. Of course, not in Bengal. Similarly, triple ride, no helmet, people are not wearing helmets, automatically detected. We don't need to deploy police on the street to find people who are not wearing helmet. Okay. Triple ride means sometimes, it is dangerous, in the motorbike, more than two people are riding, right? Automatically detected. Again, first it started from Bhopal, now it is deployed in 140 cities in India. And recently it has been deployed in Thailand, our technology, and currently deployment is happening in Malaysia, Indonesia also. Similarly, somebody is driving, while talking over the cell phone, right? Automatically being detected. Within the prison, monitoring the prison, very important. It is one of the places in Singapore, so, all of a sudden rioting broken, right? Immediately alerts needs to go, okay, so that it can handle the situation, law and order situation. Here also, assault is happening. So it is not just doing the, traditional image processing, detection of the body parts and dynamics and etc., fighting, assault, all these things can be detected, and everything is based on the, AI and DL technology. Similarly, in Middle East, the technology has been deployed because it is very, very important to protect the interest and protect the life of the field people, field engineers, laborers, right? It is very important that we give them the right kind of safety, equipments, the harness, vest, helmet, etc. So if that is not maintained, proper safety equipments are not given, insurance companies will take action. So automatic monitoring of this kind of thing in industrial environment happening. And if somebody is not wearing a helmet, immediately alert will go, message will go, the person will wear the helmet, right? So this kind of thing, this is one very interesting, video I like to show. Please pay your attention for forensic analysis. Let's say for the sake of argument, there is a bag and we need to find out who left that bag. Detecting unattended object means nothing. Who left that bag? Finding that person is very, very important, right? Once I've identified that, it is searching all the neighboring cameras, then found out this is the person who left the bag and went away, right? Who is that person? It is called attribute search. So finding the similar attribute during that time within the vicinity, so many possible people are there, right? And out of those so many possible people, we found this is the person who really came with the bag, carrying, right? Who is that person? Wearing a mask, right? Then using the face recognition technology, although they're wearing the mask, including the mask, face recognition technology will be able to detect that person. Name of the person is this, approximate age is this, gender is this, and he's a visitor and belongs to such and such. So this kind of forensic analysis tools have been deployed in many places and have been developed by AI and deep learning technologies. So this has been deployed, as I said, 140 plus cities, 80 airports, 15,000 traffic lanes are being monitored. And in Andhra Pradesh, 25,000 cameras in a single installation running all those, techniques over there. So I know that next speaker will start at 3 o'clock and I don't want to steal his time. So I like to keep, few minutes time to take the question and answers.
Thank you, Dr. Acharya, for this wonderful talk. And so I would request the attendees to ask any questions if they have.
So this is Amrita. I just have one question.
Yes, please.
So whatever application you have shown, so everything is developed in this deeper look platform?
Framework, correct.
Yes.
This first Indian AIDL framework called Deeper Loop framework, it is developed in our laboratory over here in Kolkata. All these applications has been developed based on that.
So is it, the public can use it?
Nope. It is a proprietary technology because we are in business.
Okay.
We have patent in that. And if somebody wants to use it, they have to pay for it.
Okay, yeah. Thank you.
Sir, myself, Shogata Bhattacharya. I have a question for you, sir.
Yes.
The question is, sir, in this slideshow, sir, you have shown that you have compared some cities of Europe or USA with Kolkata or Delhi or Chennai, where this technology, you said that has to be customized for India only. I mean, a technology cannot be copied, foreign technology cannot be copied, and it cannot be just copy pasted in the Indian context. So, sir, what do you think that the things that need to be stressed upon, or the things that India can implement in the technologies so that they can be apt for the Indian context?
So essentially, I have given you a couple of examples, right?
Right,
so
sir.
just bringing those technology and dumping in Moolal is not going to work. Dumping in Howrah station is not going to work, or dumping
Right,
in
sir.
a busy street is not going to work, right? So
Right,
we have to develop our own technology. That means we students, we professors, we researchers, we have to love our country. We have to take the patriotic mission that we'll be developing the technology to enhance the standing of our nation. Unless we do that, we'll always depend on the foreign countries. Let me tell you, very frankly, in many PhD committees I serve, right? And those they submit the thesis and they do the benchmarking based on the foreign data, and those papers, from all the practical purposes, those are worse than toilet papers. They are not useful, right? So
Right.
they have read somebody's foreigner's journal publication. They find out the loopholes. They do little bit of enhancement over there, and publish the papers. If that is the attitude, things are not going to change. We have to take the problems within our society. Many problems. If you look around, and we should take those problems as our BTech thesis, MTech thesis, and PhD thesis. Solve those fundamental problems. Thousands of problems can be solved. Good papers can be published. And if those are, collaboration happens with the local entrepreneurs and government pays the attention, things will change. Otherwise, we will always remain. Here are, I understand 84 attendees over there. If I ask you, how many of you are using Indian technology? In your phone, the laptop you are using, in your phone, the cell phone you are using, is anything made in India? None. We all are dependent on the foreign technologies. So the right question Sogato asked, if we have to change, we have to have that patriotic mission to build the technology to solve Indian problems for India. Short answer, I gave a long way.
Thank you, sir.
One more question.
Sir, Manideep here.
Yes.
I'm one of your students in Science College also. I have been following your lectures in various seminars and all these things. And I'm very fascinated about the passion that you show in your thing. But have you ever thought of doing something for farmers? Because there are a lot of, fields that have drought and some patterns maybe from satellite or something, or maybe, weather, etc. Because our fundamental problem is to generate crops and having, essential foods, etc. So can that be something done on that side?
Manideep, of course, those can be done if somebody focuses. There are lots of things. As a matter of fact, Professor Roy and I discussed sometime. Professor Roy, if you are present and if you remember, a lot of things can be done. But currently, I am very much focused into the video-related technologies, mainly for the smart city and make the cities safer, women safety, human safety, employee safety, all these things I am focused at this point. But yes, if there are researchers, they come together, lot of things can be done for the farmers, lot of things can be done for the medicine, lot of things can be done for pharmaceutical industries, lots of opportunities. As long as we have that patriotic mission that we want to develop indigenous technology with Indian intellectual property to serve India, it is possible. So this is the era of entrepreneurship. After you guys complete your PhD, I know, people are 99% of the people will be interested to take a techno-coolie services job, right? But some of you take the patriotic mission, lots of challenges over there, and do the entrepreneur life. I think you can change the situation of the country. It is challenging. It requires lots of guts. It is not easy to come out of a secured job and secured life. But if few people do that, the facade of the country can change. That much I can say.
Thank you, Dr. Acharya, again for this wonderful talk. And this has surely enriched us, and we definitely, sir, look forward to have you with us in future workshops and talks like this. And this was surely inspirational, sir.
Thank you very much. Thanks for inviting
Thank you.
us.
Thank you, sir. Thank you. And before moving on to our next speaker, I will request our director, sir.
Saptarshi.
Yes, sir.
Yeah, so Tinku has left.
Yes,
Hello.
sir. I think he has just left, sir. I think. Yes, sir.
So anyway, in fact, okay. So who is the next speaker?
Sir, our next speaker is Mr.
So I am
Manideep
having
Bhattacharyya.
terribly bad. Okay. Okay, so let Manideep then start, and he will be talking on a very important and interesting topic. So today, afternoon session we had Tinku. He is a very passionate kind of a researcher, and who always goes for developing indigenous technologies which will help the country. And now Manideep will be giving another very interesting talk, which is also extremely important, that is on visualization. And the data visualization is one of the most important things today in the data science arena. So, Manideep, you start.
Thank you, sir. Thank you for your nice introduction. So I just wanted to understand, is my screen visible or not?
But your introduction, of course, you
Yes, sir.
give
Yes,
a
sir.
small introduction to Manideep.
Sure, sir.
Okay.
Yes, sir. Definitely. So,
You
for our
read
next topic, we have Mr. Manideep Bhattacharyya with us, and he has about 18 plus years of experience, IT experience, among which 7 plus years in IBM, and presently he is working in ITC Infotech for the last 11 plus years as a project manager. So he has got an immense amount of experience, and today we are lucky to have him. We are honored to have him, and he will talk regarding the topic data visualization techniques, which is a very important topic in these days. So I again welcome Mr. Manideep Bhattacharyya on the behalf of CDS, Center for Data Science, JIS IESR, and we are earnestly looking forward to your talk, sir.
Thank you, Saptarshi. Thank you, sir. I just wanted to understand, is my screen visible?
Yes, sir, it's visible. Yeah.
Okay, thank you. So after this wonderful, the powerful, passionate lecture. I think you guys are surely charged up. The way he speaks, I never miss a single chance. Whenever I get a chance to attend Mr. Professor Acharya's talk, and I was always amazed, and I was always learn a lot of new things from him. Even if from my science college days, I'm always a passionate listener of him. So let's start about the topic for today, which is data visualization. Now, the very first fundamental question of data visualization is, what is data visualization, and why data visualization is required, and how it can be done? So the way I'm organizing my talk in a very simple and straightforward way, so that anybody can understand what we are trying to do. Now, what is data visualization? That first we have to understand why. Now, there are various definitions of data visualization. So there are definitions like, we need to convey some information through visual representations. Now you may ask, why visual representation? What is the problem in the graphs, or what is the problem in the tables and all? So we'll come to later. So any data visualization deals with a graphical representations of data. So in earlier terms also, Dr. Acharya discussed about a lot of graphical things. So when you put your data into graphical representations, then lot of analogy, lot of patterns, are obvious patterns are coming out, which is other way could not be understood. And try to understand that data visualization can't be done independently. It is a very interdisciplinary field. I'm just giving you a very simple example, that if I'm doing a data visualization for a credit risk, for a banking or financial company, right? So I have been given, let's say, 100,000 customers data, and I have been given also the segmentation of all the data, and then try to make some sense out of it, right? Now I have to work with a financial expert in that regard. Or let's say I'm doing something for a retail industry, right? So whoever has worked in the retail industry specifically for that particular geography and that continent, that person has got to understand, and and that they will actually tell that, yes, this particular data matters to me, or this particular data matters to business, and this could be an influencer, and this is not an influencer, and this is an outlier. So just wanted to tell you that only a single individual cannot do a data visualization unless they have a domain expertise, or they have that kind of people also engaged with. So that is what I wanted to give you a message. Now, data visualization people are essentially storytellers. So essentially, we are creating a story out of it. So I'll tell you in my, I'm in my 1 hour discussion only. I'll try to create that. Now, there are various kinds of analytics that is happening in today's world, right? Descriptive analytics, diagnostic analytics, predictive analytics, prescriptive and cognitive. Actually, now we are discussing the two extreme topics. The earlier topic was on the cognitive analytics, and now I am discussing about the descriptive analytics. So descriptive analytics essentially talks about something, or explain or describe something which has already happened in the past. Okay, so that we are nicely explaining the story, and from that one can actually do a diagnostic also, that what was the reason why it did happen. Okay, and then that lead to the predictive analytics. Now, predictive analytics means, can I find a pattern out of it? Can I show that when it will happen again, etc. So that is called predictive analytics. And finally, the prescriptive analytics, that if I want to make it happen, or if I want to prevent it happen, then what should I do? Okay, and the cognitive analytics, that is part of the deep learning and the convolution neural network, artificial intelligence, and all these things, where the system can automatically learn itself, and it can take its own decision. That is like a final end state of everything. Now, let me tell you very frankly, in the market today also, sitting at 2021, whatever analytics is happening, more than 70% is on the descriptive analytics field, even more than 75%, I would say, because only very mature organizations, they have gone to cognitive analytics and prescriptive analytics. Today also, if you see, if you want to predict something, let's say I'll tell you something, there are fantastic models which can predict the sales, okay, for a company or for, you know, certain products, etc. Now what happened is that suddenly COVID came in and the pandemic came in, and in last 2 years, whatever model was perfectly running for last 5 years or 6 years, it has completely shattered and it has to completely rewritten, okay, because none of the earlier history, nothing is now working. So the whole pattern got changed, and, you know, everything got changed. So now people are actually, instead of writing new model, they wanted to analyze pattern, okay, what is happening, because now people have to actually rely on their gut feel also a lot in terms of running the final business, okay. So your machine can give you a lot of suggestions, right? Your model can give you a lot of prescription, but finally, when you are a CEO or a CTO or maybe a, you know, chief financial officer, you have to take a decision on $1 billion, right? So you kind of finally, decide things on your historical sense or your gut feel. So there, the descriptive analytics give you a lot of support, because it kind of give you a pattern on which you can actually take decisions. Now, why we do data visualization? Okay, I'll tell you why. So there are many reasons. So I just called out all the reasons here. So primary reasons is that we want to answer questions. Okay, so let me tell you my story in my industry. You know, when we started data visualization, we created that tool, we ingested all the data, etc., and we actually placed a room just beside our CEO, and our CEO can walk into our room and ask any question related to data. Okay, so we kind of noted down all the questions, and later on, through our visualization, we try to solve. So the primary objective of any data visualization is that how many number of questions or what all questions it can answer. So answering question should be the primary responsibility for a data visualization. And then, of course, once you see the data into a context, then only you can find pattern, and you actually inspire a lot of new decisions are being taken, because you actually kind of overwhelmed with the data, and when you show things, you know, when you see things within a pattern, etc. And finally, you present a story on which you can argument. I'll just tell you a simple story. In 2015, what happened? You guys know that Maggie, the entire segment of noodles, was actually crashed. Okay, because somebody wrote an article. Even some laboratory proof was also given that Maggie contains lead or Maggie contain harmful thing, etc., etc. So what do you think? What about other noodles? Like we have noodles from ITC, we have noodles from Top Ramen, even Patanjali. There are many other noodles player. What happened to people's mind? Once you find the problem in one Maggie, okay, so people think that the entire noodles is actually toxic, and suddenly one category which used to deal with lot of businesses, it kind of crashed in a single day. Okay, now if we have to recover, we are creating a story from the pattern that, okay, these are the segments where maybe people are not watching newses or something, they are actually recovering fast, or these are the advertisement which actually works in a positive way so that this category can recover. So every time or every day, we actually, from the data, we try to analyze, we try to correlate that. Essentially we are actually building up a story on which we are actually deciding upon things. Now I'll tell you something, that data visualization is not a very new thing. It is there for maybe 4,000 years. I'm just taking a very recent example. The recent example is actually Napoleon Bonaparte example in 1812. Okay, maybe that is also around 200 years ago. What happened? If you see, can you see the lines? Okay, there is a thick line, right? The thickness of the line is actually denotes the number of soldiers they were marched toward the Russia, which is Moscow. Okay, so Saptarshi, is that slide visible? Right, you can see that, right?
Yes, it's visible. Yes.
Right. So you can see a thick, big line. Okay. So basically, just let me take the pointer. Yeah. So this is a thick, big line. So the number of soldiers, they started from France actually towards Moscow, okay, to capture the Russia. And then when it came back, you see the the lines are thickened and thickened, and finally it is narrowed down to something very small. So because of the cold, okay, in the Russia and all, they could not survive. And basically in this single visualization, one can depict the path of the soldier, even the thickness of the line that depicts the the number of soldiers they have. Even they have temperature also noted down here. Okay, there are other information also there. So this was actually done by a Russian general who actually created this picture. So this is called a figurative drawing. And this was the fundamentals of data visualizations. Even in in the time of Egypt and all, also people were doing this kind of figurative drawing. So data visualization is not from today. It is there since since the human ages. It's just that in recent technology, with the data and the advent of all these things, it has been picked up and it has become an interesting topic. I'll just give you another example. In 1854, okay, London, what happened? There was a big pandemic, okay? There was a cholera outbreak happened, like the way we have now, like a COVID outbreak. So they have terrible cholera outbreak in London in 1854. And they could not find out the source of the problem, okay? So typically cholera is what? Is a water contaminated, waterborne kind of, diseases, right? So all they have to find out the right source of the thing so that they can control. So they actually called for a meeting, and then finally the mayor of London, they actually called for a guy who kind of draws the entire diagram of the London, okay? And then from each building, he identified the number of patients, okay? Now they have highlighted, they have scratched. Now you see the entire London is pretty clean, but this particular portion has got a lot of black dots, right? Especially this building, in fact, this street itself, there were like a lot of, black dots, etc. So one can understand there must be something around this. Then later on found that in this particular place, there was a pump actually, that was the cause of the whole cholera. And even if you go today in London in Broad Street, the pump still exists today as a memorable thing, but there is no handle, of course. You cannot take out any water from that pump, but the pump is still there in the Broad Street, and that was kind of the culprit from which the entire cholera outbreak has happened. Okay, so so these are the visual depiction or representations, okay, through which one can solve a problem. So you can understand such a big problem of finding a cholera, where it is the source, etc. That can be solved using a visualization. Of course, it's not done by a computer, but by a human. I'll give you a good example of that. I have now 4 set of data. It's called Anscombe's quadrant, but forget about that. Let's say x-axis denotes your number of years of experience, and y-axis denotes the salary that you get in, let's say, maybe lakhs per annum or something. And then before you joining the company, you kind of trying to, analyze that which company you should joining in. Okay. And you have done statistical analysis, etc. So you apply all your minds and brains and techniques to arrive to the right company. Now hang on, what is happening if I do a mean of x, okay, in this data set, everywhere the mean says 9. Now if you do a sample variance of x, typically in statistics we do sample variance, right? And everywhere y, sample variance of x is also 11, everywhere. Mean of y, if you see, everywhere the mean is 7.5. So be it data set 1 or data set 2 or 3 or 4, everywhere it is 11. And if you do a mean of y, it is 7.5. It is accurate to 2 decimal places. Amazing. And then you have sample variance of y also, sy square, what we call, that is also same, 4.125. Now if you want to do a correlation, typically today all the machine learning world and statistical analysis people do a lot of correlation, right? So if you do a correlation analysis, maybe in Excel or some tool, you find that correlation between x and y, that is 0.816. And the linear regression line is also surprisingly the same. If you from this x and y, if you have to do a linear regression line, that is also the same. Now that the coefficient of r square, okay, that is also same. Now so that essentially means that these 4 data sets are the same data set, right? Now let's plot the data and see the difference. Now see this, once we plot the data set 1 represent like this. That means you have a healthy growth maybe in the company, okay? Data set 2 is what? Surprising. If you have more experience, then your salary will become less, okay? And data set 3 is very linear, that it is like a maybe government job or something, that your number of experience is always represent your salary, something like that. And this is very strange, okay? In the same years of experience, people have got different salaries. So now once we draw the picture, you have a very good understanding of the whole thing. And you know what you can actually not understood if you have not drawn this thing on a this kind of image or this kind of pattern, right? So now you understand that only analysis of data doesn't make sense unless you plot it, okay? So that is what we do. So I'll give you some more example why we do data analysis. Can anyone tell how many number of 3s are there in this chart, in this letters? Any volunteer or anything? Is it possible? Just try that out. If can anyone say? I just want to make this session a little bit more interactive. That's all. Maybe, yeah, for that. Okay, so it's almost impossible, right, to find out the number of 3s, how many number of 3s we have. But let's see that. I'll just change it a little bit. What I did is that I just highlighted the 3s and take any other data, as a shadow. You can now quickly count the number of 3s, right? You see that there are only, 3 plus 4, 7. Only 7 number of 3s are there, right? We can quickly count. I'll give you some more example, okay? So basically in our brain, we have to understand when you are doing data visualization, you have to understand how human brain operates, okay? So human can understand pattern very well, and that is called pre-attentive processing. So at our subconscious mind, okay, it takes less than a second. It takes only 200 milliseconds. So you can see a quarter of a second it takes, and it just identify the pattern, okay? So, maybe I can give another example. Let's say there is a long street, okay? You are actually standing one of the end of the street. Just by looking at the other street, you can quickly identify whether it's a boy or a girl is coming, okay? So you can understand that just by seeing the pattern. So a lot of things you can understand just from your, your subconscious mind, okay? And that took only 200 to 200 millisecond time, and we have to rely on that, because just think of that, all the executives in these companies and all, they don't have time, right? They wanted to understand the data, they wanted to understand the pattern very fast, okay? So basically the data visualization where we have the success is that basically from a chart or a graph, if just by looking at it, if you can say something or you can understand something, that means our job is done, okay? And you have to find out doing that by different kinds of contrast. So I'll give you certain examples. Like you can use the colors, right? You can quickly spot out this color is different. Or even you can use shapes. Everywhere it is square, suddenly there is a circle, okay? So you can just find out from the shape. There are many techniques, okay? We can use it. One is length. As you can see, this one is lengthier, this one is wider, or maybe orientation. So one is disoriented. So you can quickly identify there is a problem in this particular area. Or maybe some size is here, or maybe curvature, or maybe enclosure, or you can put it something little blur, or maybe you can use shape. So all sort of things are actually nothing but weapons that we use to create a data visualization, from which one can very quickly, very fast, one can understand the overall what is happening in the data, okay? That is very essential, required. So I'm just kind of putting down all the things what you can use. You can use an added marks, or you can use numerosity, or size or width or shape or orientation or spatial grouping. Spatial grouping is very important to identify patterns, etc. Or collinearity, length. You can use all sort of contrast factors to identify a data visualization thing. Now the question is that once we have discussed about what is data visualization and why the data visualization is required today, and now the question is how you can do it very easily. Anybody can do that, okay? So how you can do that, that's very interesting. Now I'll just take help of there's something called Gartner Chart. People who are in this industry, they know that. So what is happening is that every year Gartner, there's a company, they publishes a chart in all the technological fields that which all technology are leading. So they have an x-axis and a y-axis. X-axis says completeness of vision and y-axis says ability to execute. So this is also a visual representation. And quickly we can see three names, okay, on the leaders quadrant. So this is like, you know, leaders quadrant. We can see Microsoft being on the top. Then we have something called Tableau. Then we have Click. So these three has got good vision or completeness of the vision. They have, you know, really they are mature in their vision of their product, and ability to execute. That is also very important because these days people don't give you time. They want quick results. Okay, so a tool which can, you know, help you to generate a result very faster, that is always admirable and that is always accepted in this world. So I picked up three tools: Click, Tableau, and Microsoft. These are the three tools. Any of them you can learn, very easy tool, especially the one which is Microsoft Power BI, that is very easy to learn, and Tableau. Both are equal comparable tool, and one can do a quick data analysis using these tools. Okay, so now I'm just answering the question how I can do that. Now, before I jump into my, you know, demo or the examples, etc., let me tell you something that what is happening is that when you have been given a lot of options, right, then you guys actually can get confused. Okay, so these tools, they are coming up with lots of options, but you need to understand in which kind of cases what you can apply. Okay, you should not apply data visualization in all the cases for all the time. Okay, and what kind of chart you would use, that you should understand first. So there are four different kinds of thing in this world that you can actually depict or demonstrate. Okay, one is that you can do comparison between two. Okay, how red versus green is doing. Let's say how Manchester United versus Manchester City is doing in terms of new player acquisition, or maybe, you know, Coke versus Pepsi. Or you can do within your company also. Okay, how efficient your divisions are. You know, your finance division versus your HR division versus your operations divisions, how efficient they are when you are comparing between the two divisions. That is what is you are doing most of the times, because you are benchmarking within yourself. Let's say you have 4 different regions or territory on which you operate. Okay, so what is your benchmark? Your benchmark is the average between the 4, let's say. And if you are above average or you are below average, that means it decides that you are, you know, you're performing or you're not performing. So based on that, you can do various kinds of analysis. So if you have a less number of categories, then you can put the chart in a vertical manner. But if you have a large number of categories, our eyes can read actually better from top to down. So you should arrange your chart horizontally. Okay, that is a very basic principle. If you have too many categories, okay, then you should further reclassify your categories. In my demo, I will try to, you know, put examples of each of them. And if you have a cyclic data, let's say there is a seasonality or pattern. Okay, let's take a very good example of, you know, your electric bills for months, right? So that's like a cyclic bill, cyclic data. So every year, you know, in the month of November, December, January, or maybe February, you have less bill or something like that. So you can represent a data in a circular, like, you know, spider chart. Or you can have a linear chart also. If you have a 3 years horizon, you want to see the patterns, etc., so that you can see. Or you can put it like multiple categories in a multiple line chart like that. Now, most of the analysis in the industries are doing either on comparison against time, or comparison against your own categories, or it happen within your compositions. Now composition is what? Let's say you want to analyze how, below poverty level they have been benefited with the COVID vaccine versus above poverty level, how they have been, given vaccinations. Or even, let's say, job market for less than 5 years versus 5 to 10 years, and let's say 10 to 20 years. Let's say you create 3 categories, and you try to find out, and you find to do an analysis on that. So in the composition, what is happening most of the times, your total is always 100. So you kind of tend to create charts which are called stack charts, etc. So where you have a total numbers is like 100%. Let's say total population of India is 1.3 billion, out of which how many has got vaccine or how many has not got second dose or something like that. If you want to do a composition of that, so that means your total is always 100%. So something of that sort of analysis. Or it is very popular in terms of financial analysis. Let's say you are working in a financial institute and you are doing an analysis of a portfolio of your customer. Okay, so your customer might have invested in 50 different kinds of funds. So which fund is giving us highest return or yield, which fund is not giving that kind of returns, etc. So in all this analysis, you kind of do that 100% thing. Within that, you kind of try to put that multiple layers, etc. Now pie chart is a very widely used chart, but all the data visualization gurus and all, they always recommend not to use, because humans are not good at looking at angles. So I'll give you an example. Let's say if I, in a pie chart, if I have, let's say, too many categories, maybe 10 different categories, then you will not able to identify the difference between each categories, whether which one is good, which one is bad, or even if it is good, how good or how bad, you will not able to understand. So pie chart people typically tend to avoid, but in case you have only 2 categories or 3 categories at max, you can use pie chart, because this has been used for years, so you can use it. Even there are very important charts like waterfall, this one. So let's say in a production unit where a car is being produced, right? So how much time is being taken by each step, or let's say a claim in an insurance domain, okay? How much time it takes for each desk, one wants to understand, and then you kind of you end to end, you put the time. So that's called a waterfall analysis, okay? So comparison and composition are the one which are very commonly used in all sort of analysis, in all newspapers, even in TV, magazines, everywhere you will see these. But relationship and distribution, that you typically don't see, because distribution is something that is typically used in mostly in statistical analysis, that you have a large number of samples, how samples are distributed. But when we critically analyze certain data points, when we have good understanding about data points, we also do that. And relationship, which is very, very interesting and important in terms of understanding relation between 2 variables. Okay, so in this today's machine learning, etc., it is very important to have the understand the scatter plot and the relationship between the x and y. If your x is growing, whether your y is growing or not, etc. So this is called relationship. Now, as I have covered all this kind of chart, so now you understand where it should be used or where it should not be used. Let's come to a demo. I think that will clear out all your doubts, at least for the demo. What I have taken a sample data of a famous health tech company that I won't reveal the name of the company, but let us just look at the data first. And this sample, this health tech company, they have chains, like they have retail stores all over the India. Okay, I'm taking a data as India only. So as our previous lecture, Dr. Acharya, he was also inspirational about India. So I am also taking a data from India only. And what is there in the data? So the data is from a retail store chain, okay, where we have the store code. Okay, every store code is identified with a number. Of course, the store code and store name is cryptic because I can't reveal the information of the store code and the store name. So store code and store names are cryptic, but I have store types. Okay, store types could be retail, wholesale, or retail big, retail small, like that. And then every transaction is associated with a date. The date is like that. If you just carefully read the date, it is 2019-0801. That means it is YYYY sorry, MMDD. So it is actually 1st of August 2019. That is what is telling. And then we have the state, in which state the transaction has happened, what kind of product it is. I've just told you that it's a health drink company, so they produce mango fruit, apple twist, lychee, etc. And then we have the latitude and longitude of all the stores and the sales value for the store for the transaction. So this data is coming from a system. Now just looking at the data, nobody will understand anything, neither will understand, and no pattern, nothing is coming out. Now let's take a deep dive and let's see how we can do that. For that matter, I'll just open the Tableau thing. In this demo, I'll be using Tableau. I can use Power BI also, so these are comparable tool. But for that, for today's demo, I'll be using Tableau. So I'm just opening the tool. So since the tool is getting opened, I just opened, for this forum for questions, maybe 1 or 2 minutes before I go to the demo. Do we have any question on the topic that I have discussed? Because sometimes, feedback is very important, even if for the discussion or for live or for everything. Quick questions, like 1 or 2 I can take. Do you have any questions? I'm actually, taking a pause just to take one of your question, one or your questions, because I have now around, half an hour to cover up the demo. So I have sufficient time. Do you have any questions, guys?
Any questions from the participants?
Audience, yeah.
Please, somebody if you have any question, you can come forward.
Yeah, please. Because, it is important to know your audience, before you talk, because unless you know the audience, I can also customize my talk accordingly. So that is the whole objective of asking the questions. Okay, since there is no question, so a Tableau is a tool that has to be installed on your laptop or desktop, whatever you have. It can connect to many different kind of data sources that many different servers or even clouds, etc. So as you can see the names, it can connect to all kinds of Googles or Oracles or Amazon, Dropbox, whatever you know of, and SAPs of the world. And even it can connect to a file, like the way I have shown you. Let me connect to that file. Now the file is around 44 MB, this one. So let me connect to the file and let me try to import it. Now, as soon as I connect the file, so you might be seeing it kind of read the header and it identify the type of the data. So store code is ABC, means it's a alphanumeric data string, and then health, this transaction date is nothing but a date field. Okay, it has identified that it is a date field. State, it identified that it is a geographic field, and it identified that it is a type of geography is also a state, right? Then product, pack type, and it also identify latitude, longitude, etc. Now, before we analyze, we have to extract the data so that it can support all the functions. Now, extracting the data won't take much time. It will take maybe 30 seconds or even less, depending upon your data. So we have around 4 lakhs of rows that we have, and it has just now extracted. And if you see, the original data size in the text file was 44 MB. After extraction, it has become 9.7 MB. So it does a lot of compression. Now, once we see the tool is like that. We have dimensions and measures like that. It has already identified. Now let's look at sales by product. Let's see if we can find out some pattern out of it or not. So we can quickly find out that mixed fruit is having high sales, and there are small categories like grapefruit, papaya, and health drink. They are in the lower segment of the category. So let's group these categories together, because these won't make any sense. So let me just group that. Okay. So I'm just grouping these categories, and let's call these categories as others. And let me take this here and this one in the color. Yeah. Now it looks good. As we can understand that this mixed fruit is contributing highest. Green guava is next, then lychee, then apple, orange, etc., etc. We can find out. Now, one interesting thing I have to understand, whether is there any dependency or not. As we see take the pack type, so quickly what one can identify, okay, so large pack is contributing more compared to small pack. Okay, let's sort the data. There's something called nested sort. We'll use that. So let's sort the data as a descending order. Okay, this also sorted. Now just the number doesn't make much sense. For that, what I'm trying to do, I'm trying to put this on the label, and instead of number I wanted to make it % of total. Now you can quickly understand, even if you not belong from this industry, you can see that your large pack of mixed fruit is contributing 25.6%. Okay, so although you don't belong to this industry, but you can quickly see that your large pack contribution is more compared to small pack. So you can always give a quick suggestion that guys, you can focus on large pack. Even you can put more focus on mixed fruit, green guava and juicy lychee, etc., other than pomegranate and mango, etc. So typically, all Indian customers are Indian parents are very confused. So instead of having a single variant, they always prefer a mixed fruit, which kind of in one pack you get everything, right? So Indian parents think that is the best thing to have for their kid. So that's why. So let's call it as product pack. Okay. Now let's do some store analysis. Okay. We have a lot of store types. Let's see that how it kind of contribute. Now we can quickly see that retail store is actually contributing you the most, and wholesale does not contributing at all. Okay. So let's do a grouping here also, because if you have a lot of data, then analyzing and understanding is a bit difficult. So you always try to group them together so that your finding patterns, etc., would always be easy. So I'm taking store type here, and instead of this, let's use some other visualization. Okay, let's use the bubble chart here, and let's take same as % of total. So on hover, I can see the total sales, but % of total give me a quick understanding. So I'll call it as store type, right? Then unless you see the trend, nothing is confirmed, right? You should know the trend of your sales, right? So I have data for 24 months. So I'm changing the month. It's like a month, and just doing a bit of formatting. Here I just like this kind of formatting, and let's get rid of the name from the bottom. So as anybody can see quickly that it is a seasonal product. Why seasonal product? Typically you have peaks at March. So you have peak at the March 20, even you have peak at March 21. So this product is a seasonal product. So as everybody knows that in India, nobody drink juice in the winter, right? People always drink juice in the summer. So that is like a common sense. But if you are belong to this retail industry, or if you happen to be part of this, beverage companies and all, then they can easily say that, yes, it is an obvious thing. Okay. So let's try to find out that all your product, does it follow the same pattern or not? So let me take that into color. So now I can see every line is denoting each color. Yes, I can see that all the products are basically following the same pattern. So let's call it as sales trend analysis. Then let's do something. Let's analyze the data by state. Okay, let's take sales value and state. I'm just taking the two. and selecting the state from here. Okay. Now, as suggested Dr. Acharya, that it is a US tool, unfortunately, so it can't find out India very easily. So you have to specifically tell that I'm doing this for India. So you have to kind of, tell that, yes, you are in India. But this map, if you see, it is the map that, the world, the United Nations, they have accepted, but we love our Kashmir. So let me change it to our Indian map. English India. So now we got our Kashmir back, and let's change the map type to offline so that performance is better. So it's called state analysis, and let's change the color to something red green so that it kinds of quickly understand the patterns, right? Now let me do one thing. On the hover, you can see the sales value, but also what I wanted to understand is that what is the percentage contribution of sales value. Okay, so let me do the percent of total again and take that into tooltip. So I can see that West Bengal is only contributing for this company 0.41%, while Tamil Nadu is contributing 17%. And let us understand how many number of stores we have. So we call it count of stores, and let's do a count distinct function here of store code. So for this demo, I'm trying to avoid all sort of coding. Okay, I have not done a single line of code till now, but I could understand a lot of analysis or insights, right? I can see that the pattern is coming out. So this particular juice company is doing really good business in South and not doing that kind of great business in the other part of the country. Now let us understand where all the stores are located. Let's take latitude and longitude, and let's add all the store codes in the detail. One can quickly understand. Now only the store doesn't mean anything. Let's take store type also on the color, so one can quickly understand that retail stores are really presence in all the places, and there are certain cases where we have retail big stores also. So if I take our cursor, it gives you that information. For that matter, if you want to take, let's say, sales value also, and maybe let's say store name, store codes, so those things can also be taken into tooltip, so that one can just take your cursor and see the data like that. So let's call it as, let's say, store map. Now I'll do some analysis which is related to some kind of statistical base. So we have count of stores and we have sales. And if I wanted to do analysis by, let's say, store type and product, okay, so I'll do a scatter plot analysis. So just try to understand this scatter plot a bit, that on the x-axis you have count of stores and on the y-axis you have sales value. Okay, so in certain cases where you have large number of stores, okay, and so if there is a point which is towards the right axis, that means you have been present in many stores, and sales is not that high. But if you have some data like that here, let's say mixed fruit here, so in retail big stores, even if the number of stores are less, only 6,900, but your sales contribution is high, so you of course have to do business accordingly. So if you have to understand or segregate the patterns, you can take medians with quartiles like that, and then you can understand who is on your positive quadrant, who is on your negative quadrant. So in these kind of stores and this kind of product, you are not doing great businesses. So this particular chart probably tell what not to sell rather than what to sell. Okay, so maybe this is called store versus sales. Now we have created stories, bits and pieces. Let's stitch it together to create a uniform story so that I can present it, right? So let's take one by one. Let's take sales trend analysis in the dashboard, and let's take this one, and then let's say this one, and let's fit it to the interview, and then let's take this one here. Let's get rid of all the legends for the time being. We just want a little cleaner dashboard. and let's put a place where we can put these charts. Let's say this one and the store map. Now we are almost done with the analysis, but a little bit is pending. Let me just reformat this a little bit. Format it as a, let's say, modern format. And then interestingly, what I can do is that I can make each chart as a filter. You really don't have to select a filter the way you select in Excel, but you can use every chart as an individual filter. That is what is power of this visualization. Yeah, I'm done with it. And let me call it as health drink analysis. And yeah, is this visible? I just want a yes from somebody.
Yes, sir.
Thank you. Right. Now let us analyze the data, right? Let's say you are presenting a story to the CEO of the health drink company, and you have been given an hour's time and you have done a good job. At least you have identified a lot of patterns and trends, and you have stitched together everything, and then you are going to present a story. So first thing you will tell that that your large pack in mixed fruit is doing really good business, but that does not mean that in every state the pattern is same. Let's click on West Bengal. What is there in West Bengal? As I clicked on West Bengal, if I see the difference of mixed fruit and orange fresh are not that difference. So they are comparable, 31% and 27%. Even the mango juicy, typically Bengalis, they love mango in any way. So they are also kind of comparable high numbers. But if you go to other parts of the country, maybe in South, Tamil Nadu, okay, suddenly green guava, okay, something was not there at all in Bengal, that is becoming the top, even it surpassed the mixed fruit also. And even lychee and green guava, that is coming on, as a top chart. So the strategy for selling should not be same for all the states. You should have different strategy for different states. That's the first point that you can actually, from this graph, you can quickly say that. And even using a lasso tool, you can quickly understand what is the total pattern of Eastern India. Okay, so I'm just seeing the entire Eastern India pattern, and overall Eastern India, if you see, mixed fruit is going like this. So we can understand the patterns. Even we can understand where all these dots etc. are located. And if one wants to understand, okay, let's do analysis on large pack where we are. Okay, so as soon as we click on the large pack, we can see quickly all these things. Even there are very interesting analysis somebody wanted to do. Let me zoom it. I'll show you. So typically people who have gone to Delhi and all, Delhi and NCR, Delhi, Ghaziabad and Gurgaon and all these places, they are very close by, and the pattern is actually same, although it belongs to 3 states. Okay, some part in Uttar Pradesh, and Delhi itself is a state, union territory, and you have this thing, Haryana. So this is particularly Delhi. In one part you have Faridabad, you have Ghaziabad and Noida, etc. So if you want to understand what is the pattern in total, Greater Delhi or Delhi plus NCR, you can highlight all the outlets like that. And then what you can see, as soon as I click that, it kind of came up like that. In Delhi plus NCR, mixed fruit is the one which is selling like anything. Okay, if you see that mixed fruit in large packet, they are selling like 42%, and in small packet it is 17%. So if you add up this constitutes your 50%. So you should put more focus in this particular area for selling only this large packs and all these things, not the other packs, right? So in this way you can actually create a story, and basically visual depiction can actually help you to support the story, and quickly you can present it. Even you can share the data, etc. So that's the power of today's visualization tool, right? With this totally unreadable text and all, you can present like a picture. And if you see, I have very less numbers written over there. Even I don't have any traditional, what do I call, like, filters and things like that. But anybody can understand that there is a pattern. And from this graph, anybody can understand which one to focus for and which one, to not to focus for. Okay. So this is like a, story that I have presented. Now I'm just opening my forum for questions, because I have almost taken an hour. Now I have like 5 minutes left. So I'm opening the forum for questions. So if you have any questions, please ask. I would be more than happy to answer. Okay. Even my email IDs are also given. If you, wanted to reach me, you can either reach through Shaptorshi or Chandranath, or you can directly contact me. I don't mind. Yeah. And for this time, you can ask questions. So I'm pretty much done with my presentation and the demo, what I wanted to show. So how do you feel about that? Or is there something, changed in your concept? Or, what do you feel? You can share anything. Yeah.
So any question? Thank you, Mr. Bhattacharya, for this wonderful presentation. And this was surely enriching. And I would like the participants to ask any questions if they have at this moment. You can always later reach to the speaker and to ask or directly. So
Yeah.
Any questions?
Yeah, please feel free to ask, because the whole purpose or the intention of these kind of sessions are actually interactive, right?
Okay, sir. I am having one question. So this Tably and Power BI is the open source this product or not?
No, it is not open source, but both the tools, both the companies, they have came up and you can use it for free. Power BI you can download and you can use it for free. And for Tableau also, if you have a university registration or an iCard or something like that, you can just send an email to Tableau that I am a student, I want to learn Tableau. They will give you for free for 1 year. And again, if you say that, my learning is not completed, I still wanted to do some project for my some of the social cause or something like an NGO you want to support, etc., they will again give you for free. But of course, these two products are not for free, but it is free for student, you can say, and they will give you full power that all the features of Tableau you can use it with this particular tool. Whatever I am showing you, everything you can do.
So similar kind of tools is available whichever is open source, so that we can refer to our students.
There are open source tools, but you can use it Tableau, because Tableau is these days they are using it for even 10+2 students also. They are actually doing a tie-up with AICTE, even they are tie-up with CISC, with all the schools and colleges also. They are trying to educate people, and especially on the data visualization side, they're trying to do that. So they have a program actually, so they don't mind giving that for free. So students can use it for free. See, there are a lot of free visualization tools available in the market, but that does not give you this kind of enriched dashboards and things that you can do it so fast. I took only maybe 20 minutes to create the whole dashboard and present the story, right? So in any tools of that sort, in like open source and all, it takes some time. It some cases it requires some coding, but here I have not write a single line of code. Although in Tableau it supports coding, you can write Python code also, but without coding you can do many more things, right? So even if certain things which I have not shown you in this presentation, because I wanted to present to a story or something, but let's take like that. I'll because I have some time, that's why I can show. Let's say I want to forecast. Okay, so see this, I can forecast, but although this forecast doesn't really work well, there are many such functionalities. You can use it in Tableau very quickly. You can use it. Let's say box and whisker plot. Let's say you want to use, let's say for product and sales, you want to do a box and whisker plot. Okay. And let's say you want to take tag type also. So you see this very quickly you can create a box and whisker plot. Okay.
Yes, sir.
So these are the things that can be done very easily. Like in any other tool, it would take some time actually. It won't give you results so instantly. And these days, time is money, right?
Yes, sir.
So people don't want to wait, and especially people like CEO. See, there are many more aspects to it. I don't want to cover it right now because then it would be too much to share, because over the period of time I have learned also. See, sometimes reds and greens, they are decisive colors, so you should not use these colors in your graph. You should rather use a lot of neutral colors like that. Let's say I'll change this thing to let's say this one, some neutral color, so that people don't take decisions by seeing a red. People take decisions
Yes.
very quickly, that
Yes.
this is not good, this is not bad, or something. So you should be trying to avoid red or green all the time. But in case you want to show, like in this case, state analysis, where I wanted to show that south is doing good and north is not doing that good, so that's why I am putting it as a red and green color. But other than that, one should not use it. Okay.
Yes.
Yeah, and
Thank you, sir.
finally you can save the dashboards and charts, whatever you have created. Let's call it as health trick analysis demo. So in one file you have everything. You have visualization, you have navigation, you have data model, you have relationship, filters, everything encompassing in one file, and the size is only 6 MB. You can share with anybody who has got this particular software, who can open it and who can actually see it and present it. So it's such a powerful tool. So other tools are also like that only. So Power BI is also similar. Yeah.
So these kind of tools can be applicable for big data kind of things.
See, in big data, what is happening? You are you are doing a lot of analysis on a lot of data, right? But
Yes,
when
sir.
you want to present your result, you want to show your result. Let's say I'll give you an example, that a company which does insurance, right? Our insurance IRDA norms these days says that you have to approve any insurance claim within 30 minutes, something like that. There are certain norms like that. Now, you have a big data setup where it identifies whether the claim is generic or not, the person who raised the claim, whether he has got a history of such issues or other things. Or let's say you have been admitted as a COVID, let's say, I'm just giving an example, and then you are treating, let's say, something else. You are treating, let's say, cholera or something. So then they will arise a case that it is not a valid, maybe something like that. So from the prescription, it identifies all the letters, it identifies the things, and then it processes it. And finally, when it present it, right? So you have all the dimension and elements. So that is being presented through Tableau, and it is actually some of the insurance companies using it. And from this dashboard, one can understand that yes, this claim is correct, because you wanted to see the 360 degree of the claim and also the person, and there are various kinds of probabilities, okay, that are being plotted. Finally, a doctor is taking the decision that yes, this claim is valid and this person is also genuine. Finally, a doctor is taking the decision. Computer is not taking the decision. But these visualizations and all, it is using on top of all the layers, and then finally it kind of help people to understand decision, because people understand pattern, colors very well, other than anything else. So it perfectly fits to in the big data landscape. And if you see, all the connectors of big data are already present here, right?
Yes, sir. Thank you, sir. Thank you.
Sir, can you also give some information about the source of data? Is there any website which gives us such data source authentic?
Yes. There are, you can, by Indian, you can go to data.gov.in. So you get all India related data, okay? And there are many sites. If you go to Kaggle, there is a site called Kaggle, okay? That gives you a lot of data. Even data.gov.us, there's a site where you get all the US, sort of data. And there are a lot of challenges are being published every Monday. You can note it down, something called Monday challenge or something like that. You can just search it on Google. Monday makeover. It's called Monday makeover. That every Monday, there is a team run by Andy Roberts. He is actually sending a data set, and all over the globe, people are participating on that particular data set and trying to present it. So there is no price, of course, but you get to know that how the data should be presented, etc., and by which you can do a lot of understanding of the data. So you can, and this is a field that anybody can learn and pick up, and it is a lot of green field. And in industry, we really have lack of people. Although it's very easy to pick up something, all you need to learn is that some bit of database knowledge, the data modeling knowledge, some bit of domain knowledge, and the data visualization tool. That's all you need to learn, and then you can work in this industry very well. Yeah.
Okay, thank you. So we have a couple of questions in the in-call messages. So for the second question in those, you just answered that. That's questions on the similar lines. And one question is from Kritika Mitra. She's asking that which data visualization tool can handle highest amount of data in terms of performance, and how we can decide which tool will be best to recommend clients in terms of business benefit.
Right. See, in terms of number of data, so since we have only 4 lakh rows, if I would have, let's say, 1 billion rows, then I surely cannot use my own laptop to do the data visualization. I need a server, parallel clusters. So both Microsoft and Tableau, they have a lot of good story to tell. And Tableau is being used in the entire Reliance Jio launch. So as you can understand, there are, I think, 60 crores customer, I think, for Jio. And starting from the data acquisition to billing to all the analysis, Reliance is doing Tableau. Even HDFC Bank, they have 30,000 plus users that is being supported through Tableau. Even Microsoft Power BI, they also have similar case studies around the globe. So both tools are comparable and equal almost, but which one to pick for your customer, that depends on the other ecosystem that customer has. If your customer is like a pure Microsoft house, that all other tool that customer is using Microsoft, even the data resides in Azure, then it make more sense to use Power BI. But let's say your customer is using a multi-cloud customer, or even storing data on AWS or something like that, then it is better you recommend him Tableau. And both have server architecture supported, multi-cluster, multi-node, so that it support high availability, etc. Yeah, so both the tools are actually comparable in a way.
Thank you, sir. I will again thank Mr. Manideep Bhattacharyya for this wonderful talk on data visualization, and we have definitely learned a lot from you today.
Thank you.
We definitely hope to have you with us for our future workshops also.
Yeah, sure.
Okay,
Thank you, Shaptosh.
Again, thanks a lot. Okay, so
thank you.
And okay, so I think we are done, and we can always reach, all the participants can always reach the speaker either directly or through us. So that's the end of this talk. And for the next talk, to introduce our next speaker, I would invite Professor Abhishek Ray, who is a assistant professor in Center for Data Science, JISIASR.
Thank you, Shaptoshi.
Abhishek, please.
We have our next speaker here with us, and he is Dr. Diganta Mukherjee. He is an associate professor in the Sampling and Official Statistics Unit, Indian Statistical Institute. He had done his BStat and MStat from the Indian Statistical Institute, and after that he did his PhD from the same institute. He is interested in welfare economics, in particular measurement of poverty and deprivation, on which he wrote his PhD thesis. His other areas of interest are child work and health economics, and he is also interested in mathematical modeling for pricing of financial contracts and empirical validation thereof. Analysis of social networks particularly fascinates him, and he has been working in this domain along with his collaborators, postdocs, and PhD students. Some topics other than these which captivate his interest are census evaluation and latent class analysis. Today, he will be enlightening us on the topic text analysis using NLP, application in finance. So I will now request Professor Mukherjee to please start his presentation so that we can learn from him on this topic. Please.
A very good afternoon. Can you all see me and hear me?
Yes.
Yes, sir.
Okay. Thank you, Abhishek, for
Thank you, sir.
introduction. And also thanks to JISIASR for organizing this webinar and inviting me. So do I have permission to share my screen?
Yes, I think so. Shoptoshi? Can Professor Mukherjee share his screen?
So now
yes,
are
we
you
can see your
my
screen.
You can see the slide.
Right,
Yeah,
right.
If
We
you
can
see the
see.
slide,
Yeah.
then I do have permission. Fantastic. How much time do I have?
1 hour, sir.
Okay, so including question answers, correct?
Right.
So as the participants are mostly students, I think, then you are free to ask questions in between. I don't mind. Just I don't know, how do you do it? Do you raise your hand or just start asking?
Some
So,
of them,
Abhishek,
yeah, sir. So some of them raise their hands, and some of them in the in-call messages they type their question, and possibly for
the problem is that I won't be
answering
checking
the
the in-call
questions.
messages. I won't be checking the in-call messages during the talk. So if there are in-call messages, can one of you flag me? Just tell me that there is a question.
Right.
All right. So, and if any of you want to unmute yourself and ask me a question, you can just go ahead. It's not a problem. All right. So I'll go back to my presentation again, and I will start from here. Okay. So this is actually work that has primarily happened through a master's thesis of my ex-student, Mr. Soham Banerjee. So Soham was interested in finance, but he was also interested in sentiment analysis. So sentiment analysis is something that we will talk about today. So he ended up doing a master's project, which is essentially on finance as well as sentiment analysis using what we know as natural language processing, NLP. And I'm going to present some introduction to that area and then some of the findings that he obtained during his master's project work. So these are the items that we will take up one by one. I will first introduce you to what is called text analysis. Of course, some of you may already know, because I understand that it must be a reasonably heterogeneous crowd. So to be on the safe side, I will introduce text analysis anyway. Then I will talk about the applications, how it is applied in different contexts. And then we will zoom in on our particular interest, that of stock market trend prediction. And there our source of information will be Twitter. So we will use Twitter data to make predictions in the stock market. And I will also, in the end, show you a few references, websites and textbooks, which would be useful if you want to learn about this area and how to use it. Okay, so introduction. Now, text analysis is, well, in computer science language, it is also known as text mining, but analysis works as well, is the automated process. So automation is important so that a machine can do this for you, because a machine can always do things faster. So if you can teach the machine to extract and classify information from text, and text could be in any form. It could be tweets, very short, emails, maybe paragraphs, support tickets in a production process, product reviews online, like Amazon product reviews, or online survey responses from customers, any kind of text response. But the challenge is the different kinds of response will come in different syntax, in different structure, or maybe without any structure, whether we can teach the machine to extract the relevant parts out of that. And of course, we have to understand what is the relevant part. Why do we want to do this? There are many reasons for doing it. Businesses may want to extract specific type of information or keywords from these kind of messages. And moving ahead, they may want to categorize these texts from their viewpoint. So it could be categorizing with some tags pertaining to topics, or categorizing them as a positive or a negative statement, whether a statement supports their way of doing business or is critical of it. So there are different purposes for which text analysis is very much needed in businesses now. And text is everywhere. So you have books, you have newspapers, you have this World Wide Web, and then in particular you have Facebook, you have Twitter, and sometimes people also talk to each other, and you may have audio files. And this is in amazing quantities now. It is estimated that in 2020, the text data per day will be around 2.5 exabytes. And it will grow to 40 zettabytes, 40 billion TB by 2020, the total, and which is 50 times the figure pertaining to 2010. So it is growing 50 times in 10 years. And every day, the flow will become 2.5 exabytes. And of course, most of this data is unstructured. So there is no grammar to this. There is no particular way these texts are created or the messages are written. 80% is estimated to be unstructured, text-rich data. So there is enough words there. Example, Wikipedia, there are a lot of articles, more than 40 million articles, a lot of web pages, 500 million tweets a day. That's the current estimate, 200 billion per year. And then queries and searches on Google, which is growing exponentially all the time. So this is a snapshot of what our data-rich or text-rich virtual environment look like nowadays. You have social networks, you have documents, and documents also has different items which are important tags: author, description, location, whether it's a tweet, what is the timestamp, how much popular is the article, etc. So this is what we know about the text. Most of it is virtual because that's the world we live in nowadays. So what are we going to do with that? Obviously, the primary overarching objective is retrieving useful information. But this information retrieval doesn't happen straight away. You just do not copy the text from the web and paste it somewhere and your job is done. It's not like that, because that text can come very much garbled in with a lot of noise, a lot of words which do not make any sense or are completely irrelevant for you. So you have to bring up, somehow search and find the useful nuggets of information from that. And what are the steps that usually an information retriever from text will go through? They will do a part of speech tagging. Part of speech is as in our English grammar. Which part of the sentence pertains to which part of speech. Then it does something called a syntactic parsing, which we will explain. Then it starts a recognizing step named entity recognition. Based on this recognition step, there is a clustering step. remember that I said that there could be positive or negative sentiments about a particular business, or there might be clustering according to important topics. I will give examples of all that. So this is just a menu. And using that clustering, we try to arrive at what is called topic modeling. And from that, finally, we would do what is the final quantification. And we call that sentiment analysis. So there are a lot of steps to go through, and let us take a tour along that line. So what is the retrieval system? So information retrieval is essentially all kinds of techniques which will organize or represent or store and also allow you to search information in textual and multimedia forms. So when I talk about text analysis, I am also including speech or image or music. Of course, handling music is much more difficult, but speech and image are now being analyzed a lot. So the retrieval system will try to gather the material, sort it in a nice way, store it somewhere, so that I will be allowed to search for particular things in that storage. That's what is called an information retrieval system. Okay, are you all clear so far? Are you with me?
So the participants, is it any questions you have up till now?
If anything is unclear, just let us know. All right. Okay.
So most of them are replying that it's clear.
Yeah. Okay. Good. So as long as it is clear, fine. But as I said, please let me know if there is a query in the chat. Okay. So we were talking about information retrieval. Let me move on to the specific parts of this whole process. So the first part, as I said, is part of speech tagging. So in natural language processing, obviously I am using some kind of grammar. So let us say we are working with the English language, and the English grammar is our benchmark. So natural language processing takes this text and they call it a bag of words. And this bag of words may not be presented in a way that can be used straight away. So what we need to understand is what are the relationship between the words inside the bag. Let us take, for example, a statement like I like you and contrast it with the sentence I am like you. So there is only one single word that differentiates these two sentences, but the meaning is very, very different. I like you is a verb. Well, like is a verb and it expresses a positive sentiment. But when I say I am like you, this like word is being used as a preposition, and there is no positive or negative sentiment attached to it. It's a neutral sentiment, and the use of the word like is in a different part of speech. So this can happen a lot in English language. So we have to be very careful about which part of speech this word is tagged with, because the same word may be used in different ways. And once we understand that, then we come to what is called parsing or syntactic parsing. So what is syntactic parsing? It is the actual task of recognizing a sentence and assigning a structure to it. So this parts of speech tagging is a structuring exercise. It points each word to a particular part of speech, and hence it creates a structure. So this is done systematically here in this step called syntactic parsing. So suppose, again, let us talk through examples. I want to answer this question. What books were written by British women authors before 1800? So this is a question where there are multiple conditions. So I am interested in books. I am interested in British women authors. So there are two qualifiers here to the author. And there is a qualifier to the timeline. So I am only interested in books written before 1800. So there are many questions here. So if a computer were to analyze this question, this question is also a sentence, it will come up with multiple conditions. And this operation of coming up with these multiple conditions is an example of parsing. Okay. Then we talk about entity recognition or named entity recognition. What are named entities? So these are entity extraction step that classifies some named entities into some predefined categories. Suppose my categories are individuals. So some names are individual names. Another category could be companies. So some names are company names, IBM, TCS. Some names could be for places, Kolkata, Mumbai, or organization, cities, dates, product terminologies, many things. So these are all like bags, predefined categories or predefined bins. And when I have names coming up in a sentence, names are those words which are not parts of any speech, proper nouns, only proper nouns. Now they have to be placed into different categories. Simple example, Michael Jordan of the Chicago Bulls is getting a 10-hour Netflix documentary in 2019. So if I look at this sentence, I have this name Michael Jordan. I have a group name Netflix. I have another group name which is the team Chicago Bulls. So Michael Jordan, Chicago Bulls, and Netflix. So I have 3 named entities and I would like to categorize them. This would be also an important part of text analysis. So I need to understand the grammar. I need to do this parsing, categorizing into all the multiple complex conditions into simple separate conditions. And I also need to recognize named entities. All these steps will be required. If you think about it in your head, whenever you are reading a storybook, you are doing all these things. But you do it so fast and you do it subconsciously that you can't even recognize that you are actually doing all that. Okay. So what happens when you do all these things? What are we trying to do finally? We are actually trying to do an exercise called clustering. What is clustering? Clustering is I want to collect similar things, put them close to each other, put them into one box, and if things are not similar, then they should not go to the same box. As a visual example, I have say these data points on a simple scatter plot, on a simple graph, and I have created 3 boxes, green, blue, and red box. Of course, there has to be some criterion for doing this. I have not explained what criterion I am using, but suppose this is what I want to do. And why would I want to do it? In the context of a text, it could be because I want to identify which texts represent a positive statement for me, which texts represent a negative statement for me, etc. So suppose I'm looking at client feedback and I want to classify which feedbacks are positive, which are negative, and which are maybe say neutral. Or if I am looking at my services and I offer multiple services and I'm trying to find out which services are demanded more, then I am essentially clustering all the queries into different service categories. Which service category is it pertaining to? Is it asking for a plumber? Is it asking for an electrician? Or is it asking for a house painting job? So that's also an important part in clustering. Yes? Now, once we are able to structure a sentence in our automated way through parsing, parts of speech tagging, etc., and able to cluster them, then what we try to do is called the topic modeling. So topic modeling is identify topics present in a text object. And first, of course, I have to define what is a topic. So a computer must be taught what is a topic. And once I have explained that to the computer can identify the topics. And also, we will try to derive some hidden patterns exhibited by a collection of texts, which is called a text corpus. A corpus is a collection. So I have maybe 10,000 Twitter messages, 10,000 tweets coming in, and I want to sort them according to the topic they are discussing. And sometimes these indicators are not obvious because people write sentences in different ways. We can also write a sentence in an indirect way. Like when we say that something is bad, we can also say this is not great. So this kind of things is not so easy for the computer to handle. So the computer must also learn how to find these hidden meanings, hidden patterns. So this topic modeling can work through document clustering. Document means any text. It will also require organizing large blocks of textual data, because unless we are able to organize all the text information, it will be hard to analyze them. And that will bring us to the information retrieval step. And I have to remember that most of this will happen in the context of unstructured text. So I have text written in any haphazard fashion. I want to store and sort them properly so that retrieval or searching can happen. So it has to be very properly organized in a proper database. And then I want to do clustering. And this clustering can happen through what is known as feature selection. So feature selection is something that we need to understand also. So let us look at this simple picture. I think the pictures are easier to understand. I have this collection of documents organized here. So I have executed my information retrieval step. I have organized things. Collection of documents is ready with me. What do I want to do? I want to do what is known as topic modeling.
Can you please click on that hide button?
Hide. Okay, is that better?
Thank you. Yeah, thank you.
Okay. So in topic modeling, what are we doing? We first need to define what is a topic. As I said, computer needs to be taught. A topic is basically some particular set of words. So whenever that set of words, one of them pops up in the text, I say that it is pertaining to that topic. So again, I can say that, say the red circle here is plumbing work. So if I have pipes or taps or commode, these words coming up, I will say that this indicates to the plumbing topic. If this blue one is the electrical repair works, then I will look for words like fuse, switch, wire, bulb, or fan, things like that. And the green would be house painting. So I will look at distemper or design or wallpaper, all such words. So typically topics are set of words which somehow relates to each other, and if any one of them pops up in a text, I will say that this text belongs to that topic. And that is the way we will analyze a document. So in a document, we will also mark out places where it pertains to the red topic, it pertains to the blue topic, or it pertains to the green topic. And if I then do this for a large number of documents, I will be able to come up with a distribution of topics in the collection. So if I analyze 10,000 documents, I will say that, okay, the red topic came up 9,000 times. The green topic came up 3,000 times, like that. And then I will have a distribution of topics. That will help me in our analysis later on. What do we want to do finally? I said I wanted to do sentiment analysis. sentiment or opinion. Again, in computer science, people say mining, we can say analysis, doesn't matter. And it uses the natural language processing very much because it talks about natural language. What do? We identify and extract opinions or sentiments within a given text. So it is very much like topic modeling. So topic modeling helps us to do this because, as I said, topic modeling could also be about positive or negative sentiment about your business. So the aim of sentiment analysis is to gauge sentiments, evaluations, attitudes, and emotions of any contributor. It could be spoken or written. How do I do it? I will do it based on the computational treatment of subjectivity in a text. You see, this is a very subjective thing, emotion or attitude. So I want to find proof of such emotions in a text, and that computer must do it for a large number of texts. And based on that, my final output should look like this. So this is like, how happy are you with our last service request? So this could be on the bottom right here, very happy, to the other extreme on the left, extremely unhappy. And there are intermediate positions here, visually presented in a nice manner. So if I have written feedbacks, a large number of written feedbacks from clients, I would want to know what is the distribution of the sentiment across these different categories. Because not everybody will be writing in the same language, they would not use the same kind of keywords, they will have their own way of expressing themselves. But I want to collate everything into a simple one uniform class, one uniform scale, not class, sorry, one uniform scale. So that is the final goal of sentiment analysis. So any questions so far? Because now I will go into the applications. So it will be talking about how we are going to do it. So, but do you have any questions on what we are going to do here? So I have just explained what we are going to do.
Sir, in the sentiment analysis, do you also look at the degree of sentiment, or
Yes,
just
yes, of course. Yes, of course. If you see this figure here, you can see that I am not only saying dissatisfied and satisfied, I am also saying how much satisfied and how much dissatisfied. You can see that, right?
So there must be some particular combination of words.
There must be some particular combination of words which will indicate the intensity of my emotion.
For example, very bad, bad, very bad, extremely bad.
Bad and very bad has to be distinguished. Yes,
okay.
Absolutely. Anything else? Okay, so let me get into the application, because when we discuss the application, we will also be using a lot of examples, and examples always help. So what is our application? First of all, we used Python because Python as a software has a lot of advantages. It's open source, first of all. You don't have to buy, no money involved. And also Python is growing. Python is growing all the time. Every week, if you go to the libraries, you will see new features being added. So Python is like a very active university with a large laboratory. So a lot of scientists are working and they are contributing all the time, and all the contributions you are free to use. So we use Python for this applied part of this. Now, what do we start with? Now we start from the top again. So we start with the text. So text means there will be sentences or input strings. Those has to be broken down into words or tokens. So we will explain what is tokens. And finally, characters. And everything together, it will be called a document. And then, of course, there could be collection of documents into larger and larger files. And that's the structure of information that we are going to handle. And this structure can actually handle a large number of documents. So suppose we are trying to find specific texts with a regular expression. If you are looking at Facebook, you will normally look at hashtags. You can look at callouts. These are some regular expressions with a known meaning. Now, when you have a regular expression, then it is much easier to find patterns among those regular expressions. And this kind of patterns can be analyzed very easily using this particular program in Python, which is called the Natural Language Toolkit. It's an open source library, as I said, NLTK. It is popularly known as NLTK, and this is used a lot in this kind of work, in any natural language processing work. How do we go about it? Suppose on the left box I have this text. It's a medical text about athlete's foot. So it has a description of the ailment. Now, if I want to understand under which medical specialty should I put athlete's foot, then from this description, we will be able to figure out that it relates to nephrology, it relates to neurology also, and of course, because it's athlete's foot, it relates to podiatry. But I will say this particular ailment would be primarily podiatry. So if I want to classify it in one single box, I will put it in podiatry. Can you see this? You see that there are terms like immunosuppressive conditions here, which will say that this may have belonged to neurology. And then there is diabetes word mentioned here, which may mean that it relates to nephrology. But if you interpret this text as a whole, you should be able to decide that no, actually the main topic is podiatry. And this is what text classification is about. All right. Okay, so far? So I deliberately took up this complicated thing because without a little bit of complication, it would be very hard to convince you that this line of work is worth doing. It is interesting. Okay. So this is called classification. I have a given set of classes, this nephrology, neurology, and podiatry. And classification exercise is assigning the correct class label to the given input. So this box, text box, was my input, and I have to assign the correct classification here, classification tag or label. So this is what we do. And where is it done? In general, you can do this for topic identification. So you are reading news articles. Is this news article about politics, about sports, about technology, or about tourism? So identifying the topic. Remember, topic is a set of words, all of which are linked to each other, closely linked to each other. So any of those words popping up, I will say, okay, this is from that topic. It could also be to detect spam. So which emails should not be delivered to your inbox? So if there are certain texts coming up or some tags coming up, the email program will automatically send the email to the spam folder and it won't show up in your inbox. And then our most important application, sentiment analysis, say movie reviews. Is it positive? Is it negative? It is not always so easy to understand because people write sarcastic sentences. Or spelling correction. When you are typing something in Microsoft Word is continuously suggesting spelling corrections. Sometimes unnecessarily, but most of the time it is very useful. And there are autocorrect options also. If you think about it clearly, that is also text classification. Because it can talk about choices like whether and whether. Both of them are correct words, but it will also identify in that particular context which word should have been typed. So it is not about simple spelling mistakes. It's about alternative choices also. So now let me be a little bit more technical. Well, when I say technical, I'm not going to talk about mathematical symbols, but technical in the sense of concept. Text classification happens primarily in two different ways. One way is where when I teach the computer how to classify, I initially supply the computer with labeled inputs. I provide some green inputs and some red inputs to the computer to learn what is the difference between the greens and the reds. And this learning is translated into an algorithm called the classification algorithm. So the computer has learned to distinguish between the green and the red. This is called the training phase. And then I start supplying unlabeled input to this algorithm. Now I no longer tell the computer whether it's green or red, but the computer has to decide. And that is the classification model. So the classification model, for each input, will have to assign a color. Because the computer has already learned, it should be able to do it now. It may not be able to do it perfectly, but it should be able to do it reasonably well. This is called the inference phase. Okay, so there is a training phase and an inference or testing phase. So what happens here? Now in language, you have to learn a classification model or features which determines whether it's green or it is red, and also to determine the importance of these features, because multiple features may happen in the text at the same time. What happens here is that I have a set of features. Let us call them x1, x2, xn. The set is called capital X. Y is a class level. So class level can be only two, maybe green or red, or it could be more than two. The model will have to look at these features in the input text and then pick up one of these labels as the output. Given any text, it will analyze the features as it has been taught and decide on which label to put on that input. A slightly more sophisticated version of this algorithm is here, where I have the training phase also split into two parts, where among all my known data, all my labeled data, I use a part of it for the training, actual training, and then I supply the computer the remaining input without the color label to check whether it is doing the job properly. This is called validation or holdout. So these two together now constitute the training phase, because if the computer does not do this second part properly, I will go back to the first step again and retrain. Once I am reasonably happy that the computer has learned what is needed to learn, then I go to the unlabeled data classification part. Okay. Classification could be binary. There are only two possible classes. It could be multi-class, more than two classes. Life can be even harder. I can have multi-label classification where the same data point can have more than one label. Such complicated situations are also possible. We will see examples. This is supervised learning. So in a training phase, to summarize, in a training phase, I need to understand what are the features, how do you represent them, then what is the classification algorithm or model, and finally, what are the model parameters, because eventually the computer has to compute. So there has to be some parameters, numerical representations. In the inference phase, if there are only two possible classes, what is the expected level? Good, say positive or negative, good or bad, etc. And I assess the performance here in the validation step, and depending on that performance, I will grade my algorithm as a good algorithm or a not so good algorithm. If my algorithm is not so good, I have to go back to the training phase and improve my algorithm. That's how it works. And a little bit on the mathematical part of it, a very common learning algorithm is called the naive Bayes classifier. I will not spend too much time on that, I think. Yeah, I don't have that much time, but naive Bayes classifier will essentially classify text search queries into different topics using what is known as the Bayes theorem. So this is the Bayes rule. Some of you may know about it. It is just how you update your prior idea about a situation in light of new data. So I start with a previous idea, which I call my prior. And then I keep looking at the data. Looking at the data and its outcome, I continually update my information. And this updation step is called computing the posterior. And when I have enough data, when I have studied enough data, I expect that my posterior computation will be reasonably precise. Precise in the sense that if some new data comes in, I will be immediately able to tell which class it belongs to. Notionally, this is what happens in this algorithm also. If I supply enough input data with labels, the computer can learn sufficiently precisely to classify a new input. The mathematical representation of that is this Bayes rule. Okay, so I will not look at the details much, but I will simply say that in a naive Bayes classifier, what we really look at is the combination of words, which is like a topic. So when I query for Python, so let us work through this example, then we'll move on. When I query for Python, Python can be a snake. Python is this programming language we are using. Python could be as in the famous Monty Python movie. So if I only say Python and I do a query, the most common classification could be as a snake. But as soon as I change my query to Python download, this download makes all the difference. Now immediately I will say this must be the programming language, so it pertains to computer science. So this is the information updation. As soon as I see the extra word download, I update my rule and the decision changes. So this is what is happening. Okay, so let me skip this part maybe and go to sentiment analysis, because this is our primary objective here. Sentiment analysis is complicated because understanding emotions is not easy anyway, even for a human being. And for a computer, understanding emotions only through text is even harder. A text, in fact, may contain multiple sentiments all at once. In the same sentence, we can say negative things and positive things together. We do that as human beings. And computers are very uncomfortable with figurative speech. So if you say something sarcastically or in an indirect fashion, computer will be very, very confused. And if you are looking at Twitters or other such social network messages, nowadays it is not only the English language that is at your disposal. We also make heavy use of emoticons. We also use a lot of slangs which are not grammatically correct words. Instead of writing because, we write BCOZ. And the computer is supposed to understand that. So all of these things makes the analysis of sentiments a hard subject. Now, again, going to Python. Python has this very nice sentiment analysis program, which is called Valence Aware Dictionary and Sentiment Reasoner. In short, VADR. So VEDAR is a very nice program for sentiment analysis. Of course, it will not only tell you about whether the sentiment is positive or negative, it will also tell you how positive or how negative the sentiment is. Of course, that's what I said. Initially, we had that picture, that good, very good, bad, very bad, that kind of classification. So VEDAR is one such very useful program available in Python. Example. So let me start with VEDAR examples. Now, the food here is good. This is my input sentence. And the classification that VEDAR will do is that there are no negative parts in this sentence. So negative weightage is 0. A lot of it is actually neutral. So neutral weightage is 58% and positive is 42%. And averaging out, it will assign a score of plus 0.44 to this sentence. Now, if instead of this sentence, I add an exclamation mark in the end, the food here is good, I emphasize the good, the VEDAR will understand that and it will upgrade the positive sentiment to 44% so that the overall score increases. So the formula inside is a predefined combination, but what is happening is if I try to emphasize it more and more with 2 or 3 exclamation marks, VEDAR will duly upgrade the total value, the compound value of this statement, because it will put more and more weight on the positive sentiment so that the compound score also keeps increasing. And we do that in social media. We normally do that. To emphasize a point, we use extra punctuation marks. So this is what VEDAR will do. So to do topic modeling in VEDAR, the technique that is used inside, that's a reasonably complicated technique, is called latent Dirichlet allocation, LDA. And the reference is given here. I will also show it in the end, latent Dirichlet allocation. And we will not get into the the formalities, of course, but we will work through examples to highlight how this works. Now, let us take a text which exhibit multiple topics. So this is a text, a write-up on seeking life's bare genetic necessities. So this is the article. This article actually talks about genetics, talks about computation, and broadly talks about life sciences. So these are all topics, all of them are relevant for this particular text. Now, how do I quantify the prevalence of different topics in that text? I will have to look at words or string of words, sentences or parts of sentences, analyze them in terms of where they should go, in which box. So there are boxes like this: genetics, computation, life sciences, and anatomy. Now, if I have words like gene, DNA, genetic, etc., they will go to the genetics box and assign weightages like this. When I have words like data, number, or computer, they will go here, etc., etc. So the whole text will be put into different boxes with their assigned weightages. And finally, I will be able to come to a topic distribution, as in this bottom right corner. This is the topic distribution. You can see there is a lot of computation, a lot of genetics, some life sciences, but very little anatomy. That will depend on how much emphasis it gets in the text. This is the computer, this is the output. So with that example, now let us talk about the structure of topic modeling. The topic modeling is analysis of what's in a text. Broadly speaking, analysis of what's in a text. What is a topic? A topic is a theme. subject or theme of a discourse, topics are represented as a word distribution. Word distributions like this bottom right corner here. And a document is usually a mixture of many topics. You will never see, almost never see a document which pertains to one single topic. Such simple documents don't exist in real life. It is always going to be a mixture. And this is the mixture that I want to handle. Now, what do I start with? I first need to decide on the collection of the possible texts. So I must know all the list, the complete list of all these words here. Which word will go into which box and how much weightage to put on that. That list has to be made somewhere, which is like our dictionary. The dictionary has to be written. And how many boxes I want to consider. What is not known is that the actual topic of discussion may not exactly fall into one of these boxes. It may be an approximation. It may be a mixture of different topics. So then I will have to come up with an answer of in the form of a topic distribution. So this document is talking about something which is 30% genetics, 40% computation, something like that. So essentially, it's a text clustering problem where documents and words are clustered, and also there are large number of topics, and this clustering is not exclusive. The same document can actually belong to multiple topics, as I said. So there is a topic distribution. There are different approaches or modeling techniques available. So I was talking about the latent Dirichlet allocation, but you also have a latent semantic analysis. So these are different techniques with their corresponding theoretical development as well as the algorithms in terms of programs. And we are going to use Python as our programming platform. This is what we are doing. I have this document here. This document has a lot of words. So my inference will be to come up with a distribution like this with the weightages. If I am able to come up with a reasonably precise distribution, then I can also use this to generate new texts. So it cuts both ways. When we do topic modeling, when we do sentiment analysis, we are also creating something that will become auto-generative in principle. But let me not talk about that too much. Let us only talk about the inference part of it. Inference part can be complicated because there will be mixtures. As I said, multiple topics can come up and you have to put weightages accordingly. When you are using the latent Dirichlet allocation, you have to start with some modeling restrictions. So suppose you have a document, we call that D. So I have to first choose the length of the document. How long is it? I have to choose the mixture of topics. How many boxes am I allowing? And then I have to use the topics distribution of words to fill the different boxes. So a lot of questions to answer. In practice, I have to decide how many topics. It's very difficult to list all possible topics or even guessing. Interpretation can be subjective. Who belongs to which topic is not a decision which all of us will agree on. Finally, topics are just word distribution. So how do you really quantify? You have to make sense of these words. You have to generate labels, and it's a lot of subjective work, remember. So the training part, where I supply known things to the computer, is going to be very, very important, the training part. Luckily, the programming part is completely available. So when you are working with latent Dirichlet allocation in Python, many packages are available like this, GenSim or LDA. It will do all the pre-processing of the text step by step for you, finding the tokens, removing unnecessary things, and also doing the stemming, repeated blanks, etc. So given the text, it will do a lot of pre-processing for you. Of course, you have to guide the program exactly how you want it to be done, so that it can convert the tokenized documents to a document term matrix. And the allocation algorithm will actually work on the document term matrix. So I will show you. I have this WebMD text here. I want to do information extraction. So identify and extract fields of interest from the free text. So on the left, I have the free text. I want to extract all the fields of interest. Now suppose I want to extract these things: author, reviewer, time, city, main topic, etc. So these are the extractions that I am going to work with. Suppose these are my fields of interest. Named entities like news, people, places, dates, finance or medicine, and then relations. So this I have to predefine. This is my job. I have to predefine what are my fields of interest, what are the named entities, what are the relations I am going to consider. The listing must be done completely. And then I have to do the recognition. If there are nouns, then these are the possible named entities. So I have to identify which specific type they refer to: places, individuals, organizations. I must have techniques to identify all mentions of all the predefined named entities in a text, so that I can do the tagging or the classification wherever they are mentioned in a phrase. So it is not as easy as for a human being. We do it automatically when we are reading something, but computers have a hard time doing it. Example: the patient is a 63-year-old female with a 3-year history of bilateral hand numbness and occasional weakness, etc., etc. So the important tags are all highlighted by color here. And who are important, that I have pre-decided. I have a list and I am picking up the age, gender, it relates to hand, when it happens, when I am doing a workup, etc. Okay, like this one. I have this Erbitux helps treat lung cancer, simpler example. So I have Erbitux as a disease, Erbitux is a treatment that helps in lung cancer. That's a treatment. When Anita met Joseph at the market, he surprised her with a rose. This is called a co-reference. What is co-reference? Anita is a female name. Joseph is a male name. That is also going to come up in text extraction, and I have to have rules for that. So these are all rules, and I have to define all these rules. Okay. So, Abhishek, have I run out of
Yes,
time?
sir.
Have I run out of time?
It's 5 o'clock. So, yes, it's 1 hour, but you can take 5 minutes more from
So
now.
maybe in 5 minutes, because I just wanted to mention the finance part, because I have only been talking about the NLP part. So 5 to 7 minutes. Okay, so I will now get on to the finance part. Otherwise, the title will be a misnomer. So I want to go to the case study of Twitter data for stock trend prediction. So I will not get into these details again, because I have talked about them to some extent earlier in my examples. Suffice to say that my input is Twitter data and my output will be an opinion about a stock or sentiment about a stock. My example is with ICICI or ICICI Bank, and my input size is more than 1 lakh tweets. We have extracted more than 1 lakh tweets on ICICI Bank, and I am going to do the sentiment analysis using this data. In the pre-processing step or the tokenization step, I will basically remove all the unnecessary parts and find out what are the important nuggets. We will remove all the stop words, etc. And of course, Python helps us with that. Python has a library called Spacey for doing that. We will remove all the numbers and punctuation removals. We will do entity extraction in the sense that if I have BNP and Paribas, I am talking about the company BNP Paribas. So I need to recognize that these two will come together. So these things has to be done first. The information, getting it into a more structured form from the original completely unstructured Twitter message, I want to get it into a structured form. And then I will do the topic modeling. Let me, rather than talking about the abstract things, let me just first show you some examples. These are tweets related to different companies, which are actually talking about some numbers. These are numerical information being measured in tweets. Axis Bank, OnePlus, Sensex, etc. So these I can classify in one way. Suppose I call them the trade cluster, where the cluster of messages indicates some information about the actual trade, because I am actually quoting specific numbers, prices, or how many stocks are being bought, what is the rate of interest or rate of growth, etc. I can also cluster the feedbacks which are talking about feedback. I'll also talk about tweets which are talking about feedbacks in a cluster like this, table 3.2. These tweets, if you read them, are all opinions about the companies. So these are called the feedback cluster. And then there would be many other miscellaneous things coming up in the Twitter feeds, which we will have to put in a miscellaneous box, because otherwise there will be too many boxes. Because our primary focus was on the feedback, so we need to separate the important from the unimportant. So the feedback cluster, the trade cluster, and whatever remains. It's a simplified presentation, but if you make it too complicated, too many boxes, inference will be very difficult. Now, coming to the main task, sentiment analysis. All these tweets are put into the Vedder analyzer, of course, after all the pre-processing, not in the original form. And then you introduce a importance factor for each cluster to emphasize how much importance each cluster gets in our analysis, because we had too many types of things, all the miscellaneous things around that. So what we wanted to do was that we want to put an emphasis number or importance score between 0 and 1 on each text, and then add them up according to their relative presence. So what would happen when we do such an analysis? We are talking about ICICI Bank, remember? So every day, ICICI Bank has these stock prices. So this is pertaining to 2017. These are the open, high, low, close stock prices and the volume of trade. So up to this column, these are standard numerical information available from the stock exchange every day. What are we adding here? Now, for every day, I have extracted all these tweets on ICICI Bank. I have discarded the unimportant part, and I have classified the important part, the sentiment cluster, into negative or neutral or positive sentiment. And then there is a compound score. So what am I doing? On this particular day, 3rd April, my aggregation exercise gave me a very small negative score a very high neutral score, because most of the tweets would be neutral. They cannot be classified as positive or negative, and a reasonable positive score. And the compound value comes out to be something like 0.2. Every day I can do this. So I get compound values every day. When I get negative values, I put them straight into the negative cluster, which I label as 2. So all the negatives will definitely go into 2. When I have a very large positive number like 0.36 here, I put it into the cluster 0, which is the positive cluster. And the remaining in the middle, small positive numbers, they will go to cluster 1, which is the negative, neutral cluster. So for us, the nomenclature was 0 for positive, 1 for neutral, and 2 for negative. And for every day, from the Twitter scores, compound scores, we label them as 0 or 1 or 2. So this is how the final analysis works. And these are some of the references, mostly textbook type references or course material type references, which you may find useful if you want to pursue this topic further. Coursera is one, nice resource. GitHub is a very good resource for programs, software. This book talks about NLP in a very nice way. And then there is the Stanford NLP library, lot of material here. And for speech and language processing, we are referring to this particular book by Martin and Jurowski. Okay. So I will stop presenting. And I am already over time, so I apologize for
It's not a problem. It's not a problem because your presentation was the last one, and we had this time from 5 o'clock to 5:30 we had for discussion. So we can continue with the Q&A session now.
there seems to be a lot of static on your side. There is a lot of static.
Sir, am I audible?
Now you are clear. Okay, yeah, go ahead.
Sir, I was just mentioning that it is not a problem because your presentation was the last one today, and from 5 o'clock to 5:30 we had kept this time for discussions. So now we can proceed with the Q&A session. Because particularly the financial part was very interesting. So the participants, you may now clarify your doubts with Professor Mukherjee.
So now I can also open the chat box and check. So I will start from the top. Okay, so I can look at Samiratu Tosi. So what skills will you advise those who want a career in data visualization? So I think that is for Manideep Bhattacharyya. So is Manideep Bhattacharyya here?
Sir, I think he is not here, but that question has already been answered.
Answered, okay. So
yes,
and then there are no other questions. Okay, so the chat box is done for me. So now you can ask questions.
So, sir, one question from my side. This sentiment analysis on the stock data, does this pertain to the field of behavioral finance?
Yes, it can. See, this is not restricted to any particular area of research. We were interested in finance, so we worked on a financial stock prediction problem. If you are interested in political science, you can use it in a relevant context with the relevant input. This natural language processing related leading to sentiment analysis, it is a general technique and it can be used in any context. But you have to do all the classification, tagging, and dictionary construction properly, and the pre-processing of the data has to be done according to your domain. So yes,
Sure.
behavioral finance is definitely a candidate.
Okay, sir. Thanks.
So we are still open to any questions from the participants. So anyone
Sir,
who has a question can.
I have one question.
Yes, please.
This is regarding the text analysis. When we do the text analysis, the regional styles also come into picture when you do the analysis, or because for computer it is very difficult to make out what the people are saying if the language is not properly constructed or unstructured data, as you said. The regional influence also has a typical adjectives put in front of words. So in the parsing and classification, is there any process where we look at the regional accent, regional meanings of those words which they attach when they give a feedback? Especially suppose we have Amazon, and in the Amazon, when we buy a product, we write a lot of reviews about that. And if we look at the styles in which the review is presented, there is a lot of regional influences. The way they write, some typical words would be always coming into picture when they write those things. So for the computer to analyze this thing, is there any sorting method used, or it is same universally?
Excellent question. For regional usage, as you rightly point out, there will be idiosyncratic practices. Different phrases mean different things in different parts of the country. So for that, your dictionary has to be adjusted in a proper way. So what you are saying is that you have a pre-processing cluster, a little bit of clustering even at the pre-processing stage, that if your tweets are coming from people located in, say, Tamil Nadu, you will change the dictionary a little bit because the words have to be interpreted in a different way compared to if the respondents were located in Uttar Pradesh. I think that's what you were talking about. Have I?
Yes, absolutely.
Going forward, I understand that sentiment analysis outside the English language is still in its infancy, but now the natural language processing facilities for some of the major Indian languages are happening. It's a very active area of research, and in fact, Government of India has given a big project on this to a consortium of institutes so that they can build up the corresponding infrastructure for the major 13 or 15 Indian languages.
Sir, we have a question from Samiratu Toshi. Is entity notification? Is entity identification done manually, or is there an algorithm that does that?
Okay, so the first stage has to be done manually. First stage means, first of all, you have to create your dictionary of words. The dictionary of words has to be done manually, and some learning data is required where you know which entity it pertains to. You feed it to the computer to teach the computer that, okay, this will belong to this particular entity, as in the training phase that I showed. So a lot of new manual labor is involved. When we were teaching the computer to interpret the tweets properly, we had to label a few thousand such tweets manually and then feed it to the computer as labeled input. And then the computer could learn and use the remaining inputs and process it on its own. But yes, manual labor is very much involved.
So this is Amrita. I have one question.
Yes.
For text-based classification, you have shown that we can use a naive-based classification algorithm. What can be the other probable candidates for the classification?
Sorry, can you, what have I used?
Sir, we have seen that you have discussed about the naive-based algorithm for the text-based classification. So I'm asking, what can be the other probable candidates for such classification for this text NLP-based data?
So from statistical point of view, you could also use a frequent disk classification. But the problem with frequent disk classification is that it will require a larger size of input data for training. And sometimes in pure computer science, people use machine learning algorithms, but that is also very data hungry. You need a lot of inputs. So there are 2-3 alternatives possible, but Bayes classifier is more useful in the following sense, that if you do not have a lot of labeled inputs to start with, which you have done manually, which is very hard work, Bayes classifier will work well for you. The others may not.
Okay, sir. Thank you.
Sir, this is Chandan. I have a small question or maybe a discussion. So, recently, IBM Watson has came up with a new version of NLP, which is called tone analysis. Apart from sentiment, content, entity, from the text analysis, it is come up with a tone analysis that will derive the tone of a particular customer, whether it is angry, happy, or unhappy. So how, as a kind of a statistical point of view, how those tone analytics algorithm can be implemented on top of these algorithms which you are mentioning as a part of NLP?
Okay, so if I have understood you correctly, you are now referring to audio files.
Yes.
Audio recordings.
Not only audio files from the text file also. Not only these sentiments are derived, but also the customer tone is also derived by this IBM Watson chatbot. So what it does from the text, it tells whether the customer is angry, satisfied, depressed, right? Kind of a tone or the emotion of that particular customer for the text. Right?
So if it is based on only on the text, then that is exactly what we have been trying to explain. Only on the text, if you say the chat bot.
Yes, sir.
And the tone in the broader sense can also be in principle captured, because in the sequence of those chats, if you progressively move from more, less satisfied to more satisfied, that is one kind of tone. I think that's what you are meaning now, correct?
Exactly, sir. Yes,
You are not talking about the audio tone.
Exactly. I'm talking only the text
How the
inputs.
text are evolving. So there are continuing engagement. So the same customer is putting up texts over a short period of time, multiple texts, and how the sentiment of these texts are changing. That's what you are saying.
Exactly, sir.
Yes, that would be very good way of capturing this. Absolutely. I don't exactly know how IBM is doing it. Maybe you can keep the question for tomorrow, because I can see somebody from IBM Cognitive speaking in this event tomorrow.
Yes, Sandeepan sir will join tomorrow. Might we will discuss on it. Yeah, thank
Just
you,
to
sir.
add, for example, there is a question that how was the product? If somebody says bullshit, and the other fellow said this was bullshit. Now, if somebody uses just one word that it was bullshit, then it means that he's really very, very angry with the product. And if somebody is using a long phrase to explain, then he's still, I mean, that's my feeling. So there is a tone also in the way the customer replies to a particular question. And maybe that part is what he's referring to in the analysis.
But that part is already done, because you see, we were looking at the aggregate score from a sentence. So if you use a long sentence and there are certain words which are neutral and some words which are negative, then the total score will become slightly less negative, because I have used some neutral words. Remember in that example of the feedback cluster?
Yes, sir.
Yeah.
We added that exclamation mark.
Yeah. So that is not so hard, but I think the tone is more more nuanced if you use a sequence of texts in a chat.
Maybe multiple times.
That somebody starts very angry, and then probably through interaction his anger is reduced, so the tone is changing. So if IBM is doing that, that would be a fantastic product, I think. But I have to learn about it.
Yes, yes, sir. I have pasted a link of that IBM Watson, that particular framework that they have built on the chat website, maybe for other students and for students like that.
Yes, I can see that. Okay, okay. Thank you so much.
Thank you, sir.
All right. So, are there any other questions, comments?
Any questions? Any remaining questions from the participants? So, sir, I guess they have got the understanding of the topic. And first of all, I would like to thank you very much on the behalf of Center for Data Science, JIS IESR, for this wonderful session. And this has definitely been enriching, sir. And we definitely look forward to have you with us for our these kind of future workshops and talks. Thank you, sir.
Okay, you are welcome.
Thank you, sir.
It was nice.
Thank you, sir. And one thing, sir, just I want to mention that today the attendance was quite heartening because we have attendance over multiple countries, not only our country, but from multiple countries we have our attendance, and they have been asking questions and participating actively in the webinar.
That's good. That's very good. Good news for JISIASR also, because you are then reaching out to a lot of people. That's nice.
Thank you, sir.
Okay. Thank you then. Bye-bye.
Bye, sir. Bye.
Thank you, sir. Bye.
Thank you. Bye, sir. So this marks the end of today's workshop, and we will definitely meet tomorrow from 2 p.m. And any other questions, if you have any questions for us, you can ask us. Otherwise, it's done. We are done for the day. Have a nice day, and we will meet again tomorrow.